调适与环境治理国际论坛暨座谈会的下午场次。Ladies and gentlemen, welcome back to the afternoon session of today's symposium and forum. 下午，首先我们将以气候变迁为题。In this session, we're going to focus on climate change. 接下来，让我们邀请来自欧盟的专家 Dr. Juha-Pekka Japola, EU Commission Policy Officer, 来到舞台上。Now we would like to invite our speaker to come up to the stage. 他要演讲的主题 He will talk about the EU's disaster risk management and climate change adaptation. 我们请现场的贵宾掌声欢迎讲者，有请。
Hello everybody, I'm just trying to check if my clicker works first of all, so... Does it work? Sorry? Oh, it doesn't work. Hello everybody, well they try to fix up the technology. My name is Juha-Pekka Japola, I'm usually called just JP because it's a lot easier. Maybe I'll go back once more. It's the first two letters of my first name. I work for the European Commission, which is, to make it more simple, it is basically the government of the EU, and I work for one Directorate General, which basically are the ministries of the European Commission. So I represent only one ministry basically here, unlike the super ministry that was mentioned earlier about Korea. But I will try to give you anyway a more comprehensive look about the EU. I think it will complement very well the ministers and the ambassadors' earlier keynotes, and I will give but without further ado, I will talk to you about a little bit of the context of climate change from a European perspective. It is quite similar as the previous examples and so on, but hopefully I can complement some parts of it. Then I will give you the EU's current policy and future, both short and long term, relating to climate change and disasters. And then I'll give a few practical tool examples, because as the minister was saying in his last slide, it's not only about knowing and it's not only about wanting, it's also about action. And also, as the ambassador had, that there needs to be means of implementation, finance, money, and so on to make use of it. And we usually love that aspect of our work. And just for like background, our ministry and me usually focus on disaster risk, but as I said, I will try to complement also with more adaptation and biodiversity and environmental aspects too, but my main background is on disaster risk. And the picture you see over there is from, I think, 1 month ago. The ambassador had an example of France having record heat waves, I think 20 years ago, 25 years ago. And this year is the same again. So that picture is from France, where they were fighting record-breaking wildfires. So I don't think I need to repeat this slide again. It's been mentioned multiple times already that 1.5 degrees centigrade is about to be, it's not permanently breached, but about to be breached already. But this is the same data set from the EU as well. But then there were multiple record examples by the ambassador and the ministers. I don't think they mentioned wildfire at any point. Maybe it's not so common over here. There were floods and cyclones and so on. But this is a record-breaking wildfire currently happened a month ago and might still continue in Europe. So that's a picture from Spain, I think, where if I remember correctly, it's the forest fires that had been ongoing in Spain and Portugal were 246% higher than ever recorded. But the recordings go only back 20 or 30 years, like the accurate recordings, but it is still the biggest of the wildfire ever in Europe. On the diagram over there, you see that, which is personally also worried, that because when wildfires happen, of course, it causes a lot more emissions. So it is a record-breaking emissions coming from the wildfire. So it is a negative or amplifying loop to climate change. But thankfully, this is one record, or not thankfully, but one record, different format that was in Europe than unlike here, but the same trend happened in Europe too, that records are all the time being broken. This is a very, very complex slide, but it contains a lot of information, but I'll try to walk you through a little bit about it. So the EU has a mechanism, I'll explain a little bit later more, but where basically the EU coordinates support between member states and also internationally for all kinds of disasters. It doesn't only contain natural disasters, it also means man-made. So there's conflict and conflict among over there. You can see in the map of Europe that it is also providing support to Ukraine. It also has population displacement, so like migration coming out of natural disasters, but also pandemics. So for example, COVID is over there. And this map, you see all the tiny symbols over there and the countries with different color codes. It means some country has assistance from the EU mechanism. So EU has deployed its reserves or in-kind assistance from the EU member states, either within the EU or internationally. So any country can ask for this assistance. It doesn't need any other agreements before it. So it is one form of kind of humanitarian aid. You can see that it is mostly within Europe, between member states, or South America and Africa. So there's not that much happening in this region, which is also naturally that this region is a lot more resilient to natural disasters as well. On the very top, on your right side at the top, you can see the trend of these activations. So once it's always activated, a country asks for help, and it is accepted, the plea for assistance. Of course, it's recorded. And you can see the trend, those have been also going up. There's 2022 is a little bit of an outlier, that's COVID, but otherwise you can also see a similar trend over there that countries are asking more and more assistance from the EU mechanism because they cannot cope with their national measures alone. This is one, I think this might be the last slide of graphs, but the EU also provides humanitarian aid, which naturally also is affected by climate change even more in Africa or vulnerable countries like the ambassador was mentioning. These are just some simulations. We're into 2100 of where the need for humanitarian aid could go in the current SSP2 scenario. And mind you, these are simulations, but you can see at the moment we are approximately at 300 million people per year need humanitarian aid by the UN standards all over the world. I think this data set is 26 countries or something like that. And there are different kind of severity simulations over there, and most likely it would end up by 2050 around 400 to 600 million people will need humanitarian aid, at least in the world. But last but not least, out of the trend of climate change, this is the part where the EU is most interested about in Asia. So the conference is super well organized. All the public transport is super well organized in all parts of Asia, including Taiwan, as I've noticed in the last couple of days. It's a total difference to Europe. Europeans are not in any way as well prepared for disasters as people in this part of the world are. You can see one Eurobarometer, I think a year ago, that 65% of Europeans feel they need more information to be able to prepare for disasters and emergencies. It is totally different over here. Well, similarly, Europeans also support that EU objective of becoming climate neutral by 2050. Then if I explain a little bit of the mechanisms and the policy at the moment. So this is the disaster risk management kind of tool or mechanism or overview of it. So as I mentioned the mechanism before, it contains 27 EU member states, so the whole of EU, plus 10 other participating states from mostly from the European neighborhood. So your Balkans, Ukraine is part of it, Iceland, and so on. But that is basically the core that can provide assistance to each other or externally. You can see in the infograph over there how it works, but I would assume it's kind of similar if in any Asian country as well, or if you take Asian or Taiwan, that one country asks for assistance, they declare there's a disaster, and it is processed through different kind of bureaucratic steps, and until then, whatever is needed is mobilized from the reserves, like for example shelters or flood pumps and so on. So, mind you, the EU only has a mandate to support and coordinate the member states. So the member states are always in control of their what they provide, what they ask for, and what they decide to do with their national adaptation. Like the ambassador was mentioning, the national adaptation plan. So the EU does not harmonize, the EU does not tell them what to do, we only support and coordinate. But in the slides previously and over here, we are only talking about, let's say, response when a disaster happens, and also that was a little bit in the minister slides, but there are many other tools behind this mechanism and EU's disaster risk management, like the reserves, there's training all the time for different member state people, there's capacity building. I'll have in the later slides a little bit more about research and innovation support on this. And I mean, it would take an hour to talk through all of them, so I will skip you that. But then there's also different funds, like the Cohesion Fund or Solidarity Fund, that can be activated after a disaster to rebuild back, and that comes from the EU budget as well. Okay, so that was what we usually call disaster risk management, but then we have different tools for climate change adaptation, and I assume it might be the same over here, that these are often a little bit two different sides of the same coin, that what is adaptation and what is disaster risk management. And these are not, again, all of the tools at disposal, but for example, the EU mission on adaptation to climate change, it's, since we are at NERA, and we are is very research-oriented, but in the sense that the research should always become capacity building in the end. So whichever researcher is contracted to do a research project around it, and I'll discuss it a little bit more later on, but it should in the end have built a capacity in a region or municipality and so on. It was 2 years ago, the European Climate Risk Assessment, the EUCRA, was published, which identified 36 climate risks to Europe. It was the first time ever that a European climate risk assessment was done, and it was produced by the EU's similar agency, that is NERA, so the European Environment Agency, EEA. And they are now doing the second one. I think it should be published 27 or 28. And other means of implementation, again, there would be a long list, but I guess most of you know what is Horizon Europe. Anybody who knows Horizon Europe, raise your hand. Only one, two, three? Okay, well, that's going to be a good discussion later on. But Horizon Europe means the EU's research funding, and it's available also for outside of the EU. But specifically for adaptation, only in this mission, there's 100 million euros per year plus available, and the total number is way bigger when you take everything else. And euro is almost the same as a US dollar, so if that makes it easier for you. So that was the existing part. Here's latest now new developments that have been adopted or will be adopted in the coming year. So there's what is called the Preparedness Union strategy published March 2025, because the EU has a new commission or new government starting from late last year. And this starts going already to what I was saying about that, in what way Europe is not as well prepared for disasters as Asian countries are. For example, that it's very segregated, that the citizens might not think that they need to prepare themselves for disasters. Or like, if you've ever been to Europe, getting into a metro is a total catastrophe compared to getting into a metro over here. So that kind of, the same thing happens all over in Europe, that the population itself is not as well prepared as over here. So one main aspect of the strategy is that it's supposed to be whole of society. Like the quote from our commissioner, which is basically the same as the EU minister, preparedness must be woven into the fabric of our societies. Everyone has a role to play, because it's mostly now like an official bureaucratic level that does it. And mind you, it's also, as I was saying in the previous slide, it's also complement. It's not only natural disasters, and it's not only natural hazards, but it's also conflict or human-made threats at the same time. Because of course you can use a air raid shelter or air defense shelter. You can use it also against a natural disaster, or like food pallets are the same for both natural disasters. So it also includes security and military threats in the strategy itself. And later on next year, there will be a new, it's a very long name. I hope they will change the name because it's very long, but Integrated Framework for EU Climate Risk and Resilience Management. But in any case, it is responding to the same requests that the Minister and the Ambassador were saying, that there needs to be more bolder action. And this is coming from the European Parliament and the European member states. Then if you go into a more longer term, so the EU has a long-term budget always, it's 7 years. Next one is now being drafted, so it will start in 2028 and it will run till 2034. And this is basically the biggest interconnected policy of what the EU will do in the next 7 years, because not just the ambassador was saying that it needs money. everything else is just words if you don't have money around it. And mind you, everything is now a proposal at this stage. So the Commission, the government, has proposed it to the Parliament and the Member States, and it will be only completed in the next 2 years. But this gives a bit of an indication where the EU in budgetary and in concrete actions would want to head to. So Horizon Europe is EU's flagship research program. It is available all over the world. Anybody can participate. As you know, since 2003, Taiwan co-funds Taiwanese research to participate, and there was an info day in February 2023. I think Taiwan can only participate in the sense that Taiwan brings its own funding to it. But then, for example, Korea joined, start of this year, Korea joined Horizon Europe, so they can now fully participate in Horizon Europe, that they can get EU funding for their research projects. And Japan is in the formal talks to become a member of Horizon Europe. I think it's expected next year. But you can see from it is the last 7 years, it has been 90 billion euros for the whole 7 years. So that's quite a lot of money to run into research only. That's the whole, everything around it. So it's also industry and culture and so on. It is proposed to be doubled for the next 7 years. So there would be 175 billion euros in the next 7 years available in Horizon Europe. And as I said, this is available globally. So there are research projects with Australia participating, and as you know, Taiwan has been participating in some of them. And this is by far the best way in research area to collaborate with the EU, because it is meant to be, science cannot be just one country or one continent alone. So it is open for everybody. But then there is the pillar 2 in the middle over there that is usually available globally, and it goes into different kind of sub-areas then. And I hope you can see the smaller text. There's 1, 2, 3, 4. Those are the areas that is meant to be in the next area. So, for example, there's clean transition for more mitigation-related projects, but also resilience and security that would be more adaptation. These are more EU internal, then they're not necessarily available, but gives you a bit of an idea again how EU is proposing to also deal with this. Again, more funding proposed for crisis preparedness. So I was saying that it also involves security threats, hybrid threats, and so on. Not only disasters, because they can be complementary to each other. And as I think the minister was saying, that how would the military help around it? And also, similarly, I talk mostly about adaptation and disaster risk, but similarly, there is a funding, even more funding being put into clean transition and mitigation. So the climate targets that the EU has set that to be climate neutral by 2050 are still in order, and there is meant to be 700 billion euros in the next 7 years if this is accepted to go into among others, mitigation, but other projects as well. I'll give you I'm about to end. I'll give you a few examples of how the mechanism works in actuality. And there's even more, if you want to look at the QR code, there's an even more cool way of explaining this one. So, and mind you, Europe often has a bit of silly trademark names or names for their different kind of tools. So this is called Rescue, and this is a crisis reserve shared by all the member states. So part of the slides I had earlier, how the EU can send or coordinate sending different kind of reserves around the world or within Europe. So, for example, you see on the green slides over there are firefighting planes in different EU countries, and they can be requested and sent, pre-positioned, sent to support in different kind of disasters when a country calls for it. And in the blue ones, you can see shelters, and I think those have already been sent to, for example, Turkey. There was the big earthquake, I think 2 years ago, and they've also been sent to Ukraine. But if you want to look at the infograph later on, that is a way better way of explaining it. And I think it is a second last slide, so coming to the end, a bit more already minor technical, and these are mostly available for EU member states, but gives you an idea how we support our member states. But the first one, the Civil Protection Forum, it's going to be next year. It is on disaster risk management. It is the biggest event in Europe. It is an open event, so if anybody wants to be there on 4th or 5th November 2026, you're very welcome to come. There are other events too, like the adaptation mission forum and so on, but that's as a one example. But they are usually open, that anybody can come to them. They are very often not invite only. We provide a lot of very technical grants or assistance to our member states for different kind of projects that operate very similarly to Horizon Europe. So somebody applies and it's evaluated and EU gives them money. Okay, these are just project names. If somebody wants to look, you can find online more about. But Empower Citizens is, for example, to build community-led preparedness in different communities around Europe. But I was saying that European citizens are not as well empowered and not as well self-resilient as Asians over here. So that's one project. And Cross-Flood is a full-scale exercise, which means that the EU member states exercise together. They go to one country and they basically simulate whole disaster, starting from sending the reserves, sending help to one country, and then handling the disaster and so on. There's 2 examples of Horizon Europe topics. So the draft topics for 26 and 27 are already public. So if somebody wants to already start looking, you just go into Google or Bing or whichever you use to search, and you put draft Horizon Europe topics for 2026, 2027, because it takes a long time to plan these, of course. These are multiple million or tens of millions of euros projects, and it usually requires a big consortium. So for example, if you would do it with the European partners, it takes months to plan it and months to prepare the proposal, but there's only 2 I mentioned over there. There's hundreds of topics available on different kinds of aspects. And usually they go from, let's say, minimum is 2 million euros for the whole consortium, or the whole team of universities or other authorities. But it can be something like 20 million as well. And as I was saying, likely a very interesting aspect that this region could bring to Europeans is the whole of society aspect, and how our citizens are more prepared on themselves to disasters and climate change. And my final slide, I hope I wasn't too long. I'm Finnish, so I'm usually quite quick about it. But to conclude, the EU is proposing, and I say again proposing because the Parliament and member states have not approved it yet, but it's proposing very significant upgrades to crisis preparedness, which includes climate change adaptation and disaster preparedness as well, and also the clean transition for the next 7-year program, so to the amount of doubling some of them. And our main instrument for any kind of structured collaboration internationally, so also with Japan, Korea, and Taiwan, is Horizon Europe, as I mentioned. And I encourage anybody also to be aware of it, or to investigate how you could participate in it, because then when you have a grant or you have a project, because then you can collaborate all the time with for example, with a European university or European institute or European company and so on. So it becomes a lot more normal. And as I've been saying, we call it a culture of preparedness, but we think that culture of preparedness, like in the whole society, is much more advanced over here. Like I was saying, the metro example, that here, if here's the metro door. In Asia, everybody waits for people to come out. In Europe, everybody is waiting in front of the door, so nobody can exit it. So all the time, these kind of things happen all over in Europe, that there is not such a similar culture that if there's an early warning, Europeans might do. Whereas here, you have a cyclone warning, the population might take it a little bit more seriously than Europe. Okay, I'm characterizing a little bit, but that is the part we are mostly always impressed about. And I will end there. I hope I was still on time.
All right, thank you very much, Dr. Japola, for your wonderful sharing, and you have excellent time management. Thank you very much. Please return to your seat. 我们谢谢来自欧盟的讲者跟我们分享有关于欧盟的经验，还有许多的专案计划。上一位讲者，我们要邀请到的是交通部中央气象署吕国成署长。Now we would like to welcome Director General Guo Chenlu from the Central Weather Administration (MOTC). 他要分享的主题 ，He will talk about from weather monitoring to climate action, building national early warning capabilities for extreme weather。我们掌声欢迎署长。
Good afternoon, everybody. I am Guo Chenlu from Central Weather Administration. I'd like to share some experience in Taiwan about extreme weather and how the CWA try to monitoring the severe weather and supporting the country, how to face the disaster coming, and how we doing about the so-called early warning capacity building. Yeah, and I will follow the 4 part. First, I will show the climate threat around Taiwan, and then how we doing the so-called early warning for all any sector or any kind of the people, and how we do the climate service, and then give some summary. I think, yeah, this trend, just Dr. said, this everybody very familiar about the trend for the last from the last century to here. In Taiwan, it's average temperature rising about 1.5 degrees Celsius 100 years, and you will see so every year they have some fluctuation, and of course at this time we highlight the significant weather or climate event. It will show that the threat of the climate, severe weather or severe climate event were getting more intense and getting more frequency in Taiwan. Okay, just Dr. Peng showed this early morning. Yeah, the track of tropical cyclone is getting changed a little bit. For example, last 2 years, there has 2 tropical cyclone landing in the western side of Taiwan. I think that in the previous year, I think about 40 years ago, there had once a tropical cyclone landing in central Taiwan. And last year and this year, that occur, okay, again. And besides typhoon, in typhoon, for average about 4 major typhoon attacked in Taiwan every year. And torrential rain, we expect about May and June is a rain season around Taiwan. At this season, it's easy to get a flooding on the western side of Taiwan. And the drought, and for average of 5 to 10 years, they have severe drought around Taiwan. And the cold surge about every year, they have 1 or twice. Okay, you never think that in the threat of northern Taiwan getting snow in 2017. Okay, it's a very extremely case. And the heat, I think in Taipei, we experience a whole month temperature greater than 35 degrees. Okay, so the hazard in Taiwan weather is very extreme. And how we predict those information and let the people to get the early warning and more time to prepare is the most important job in Taiwan, especially in the Central Bureau. So how we do the early warning process, we can say the 2 parts. One is the know the disaster. That's from education and from outreach to let the people know the disaster risk knowledge, and then how we detect the severe weather, and then to monitoring those kinds of the situation to give the warning to the public. And then we have to do the preparedness, we have more communication to the public. And then how we disseminate this information to the public. And then as they receive those early warning messages, and what will they do? This our strategy for Taiwan. And monitoring forecasting, I think this is basic concept in the meteorology. That we need a more sensor around Taiwan, and then we need a radar, remote sensing to collect the information from radar, from satellite, and then we need a supercomputer to forecast the future phenomena and to get the information best to issue the warning. And as I show this, currently there's around more than 1,000 rain gauge and automatic weather site around Taiwan. For average about 5 kilometers, we have a wet temperature sensor, the humidity sensor, pressure around Taiwan. And besides that, over the sea, we have a lot of the buoy and the tide system around Taiwan to collect the information threat from the ocean. And then we have the radar civilian around the Taiwan. For example, we have a 4 S-band radar. There's a long-range radar. They can detect about 460 kilometers longer. So once the tropical cyclone approaching Taiwan, it's easy to detect the structure and the precipitation type. For example, this is a typhoon. In the previous year, the typhoon from Taiwan eastern side to move northward. So the radar can not only detect the rain intensity, it also can detect the wind speed intensity. Just Dr. Peng said this morning, in the early of this year when the tropical cyclone landing to Jiayi, and before it landed about 4 hours ago, we directly detect the typhoon intensity and we issue the warning to the local area when the typhoon will get landing. So this is a good example for early warning message passing. And we also put those information to the numerical model, and we use the high performance computer to doing the forecast. And basically, we have different kinds of numerical model. One is a global model. It can forecast all the global weather condition. And then we have an ocean model to forecast the ocean condition, the ocean temperature, and the wave height, etc. And around Taiwan, we have the higher resolution model. The higher resolution model can detect the convective sail. For example, the thunderstorm, the model can detect the behavior of the thunderstorm. Then we can issue the heavy warning. For example, in the Sunday, I think this Sunday we have a heavy precipitation in Taipei in the late afternoon. At this situation, we really give some alert in the morning of Sunday. At that time, the Taipei County and New Taipei County, they have established the local warning center. And in the afternoon, when the thunderstorm occurred in the day afternoon, as I know, the hourly precipitation was greater than 80 millimeters in Taipei. So at that time, the local government can take action and prepare more action to prevent the flooding disaster. So we have different kinds of model that's handling for short time to the hourly scale to the 3 months, even to 8 month scale to provide a different time scale warning information. And recently we have cooperated lots of the information to do some downscaling process, because in the global model there has coarse domain scale. For example, in the global model, for average about 25 kilometers a point. And in the small scale, the numerical model can predict more precisely. So last year, we cooperated with the NVIDIA to downscale, to doing the downscaling process by using the generative correction and diffusion model. We call it CORDIF. It's successful to downscaling from the coarse scale from the global model, just we see in the left-hand side. And we use the downscaling process, use the AI technique to transfer into the small scale situation. So we can see in the right-hand side, you can see when the tropical cyclone moving from the southeastern part and moving to the center of the box, the resolution again higher. So we successfully downscaling from 25 kilometers to the 2 kilometer scale. And so it can easy to depict the center of the tropical cyclone behavior. So we can use this information to do more precisely weather forecasting, to provide those people to have a more message for early warning. And so how we issue the early warning message to the public. In the beginning, we have a 7-day forecast, but 7 days is not easy to precisely describe the typhoon or the heavy rainfall behavior. So in the 7-day forecast, we show that outlook is a text mode to show is there any potential the typhoon will approach Taiwan, or is possibility to use the typhoon will land in north or not land in south information. Once the typhoon getting more closer, for example, in the one-day scale, we will issue the advisory. They will include the torrential rainfall area, even in the strong wind area. In the different kinds of the weather pattern, for example, the high temperature event or low temperature event, even the dense fog or strong wind or tropical depression, we will issue this information in alert stage. Okay, they call it advisory. Once in a few hours, in CW, will issue the warning status. Okay, for example, typhoon getting more closer, we will issue the sea warning or land warning. And the local government at that time will, based on the wind forecast or precipitation forecast from Central Weather Bureau, to decide if the local government will shut down or not shut down in tomorrow. So every people is this information is very crucial and very depressed when the government did not say, oh, the government will shut down. Yeah, and it's very important to CWA to issue this information because it's causing the life safety. And for example, in typhoon status, when the typhoon just genesis, we will issue the kinds of the information to have outlook stage. When the typhoon or tropical depression was formed, and then we'll issue the track of the tropical cyclone, and besides that, we'll issue the potential risk area and wind speed probability. And once the typhoon more closer to Taiwan, we'll issue the typhoon warning. At that time, we will issue the more and more wind and precipitation product for the local scale, even down to the county or township scale. That will more helpfully to the local government to make a disaster prediction. And this is the kind of product that I show you that once the typhoon occurred in the South China Sea or around Taiwan, when it approaching to Taiwan, at this stage, we'll issue the potential track area. And then we also show the probability of the typhoon hit. And for example, you can see the bar of in the time series, it was really easy to detect or to show when the typhoon could be affected this area in a strong wind probability. Okay, this is the kind of product that we communicate to our user. Also, the product is very important to CWA to communicate to the different kind of stakeholder or the user, and they have a different way to show the information to the public. For example, the CWA official web page and mobile phone, we can have an app. And then we have open data to the public. And we also show from fax or from message and some 24-hour hotline. And in the typhoon stage, we will hold a media conference for every 3 hours. And even the social media like Facebook will issue the special kinds of the image or graphic to the public, to let the people easy to access the information about the tropical cyclone warning or typhoon warning. And in the severe conditions, the CW will issue the extremely information via the cell phone. So just like earthquake, you can get the cell phone warning. So even the typhoon warning, we will issue the cell phone information to the public when the typhoon was landing. So just Dr. Peng said this morning, in the eastern part of Taiwan, it's about more than 400 people received the strong wind warning at that time before the typhoon landing 2 hours. So this information is very, very helpful, I think, to the public. And then recently we are thinking about the weather information is not only show what the weather will be, we are transferring this information to the people that what the weather will do. Okay, not only we just show them oh, tomorrow will heavy rainfall, we'll show them tomorrow somewhere could be have a road flooded. Okay, we are thinking about how to manage our information. So we have lots of conference direct to the people. For example, in the last about 3 years, we have a workshop for agriculture, fishery, etc. We also face-to-face to the fishermen and to the farmer to show how they use the weather information to make some adaptation even during the climate change or the environment change, especially for the severe weather or the high temperature or maybe more frequency of the flooding, etc. And as we discussed, has some conclusion or some sustainable agreement. We are collect a lot of people to define different kinds of the warning level. For example, we will define the red signal, yellow signal, or green signal that depend on the risk level. And then we, as a CW, issue these kinds of the label and how the action the people will do. Okay, this is very important to communicate the people to show the kinds of the product. And even the event is beginning, okay, and CW will have lots of the channel to discuss with the different kind of stakeholder. For example, when the typhoon will impact Taiwan, in the CW will hold a conference to the disaster management. And when the typhoon is landing Taiwan, we have more discussion to the local government and even to the Central Emergency Operations Center to have more collaborate and more data transferring to make the difference, the thinking for the tropical cyclone information agreement. So to the public, it's not easy to discuss directly with them. So we use the so-called public weather warning service. This is an example when the thunderstorm occur in the mountain area. In the lowland area, it's easy to flooding. And that time, we are sending the so-called PWS, and the people in the lowland area, easy to flooding area, they will receive the message from the cell phone to understand their location is possibly have some risk at their location. And then keep them safe is the most issue that we try to send those information for. And besides that, the climate service is very important as well. In the climate service, we are trying to build a national framework for public service in different kinds of sector. Also, the target area include agriculture, disaster risk, water resource, and energy and health. I will show you some framework that was held in CWB. It include, we have for farmer, we have show the farmer severe weather and farmer weather information on the farmer website. And to the green energy sector, we have generate a green energy prediction website. And for the ocean or for the fishermen, we have a marine meteorology website for them. So climate service information system is very important to helping the adaptation of the climate change threat, the information about the weather to the public. And this is the agriculture at the forecast platform. Basically, this is a cooperate between the Ministry of Agriculture. At this page, we'll show the real-time weather information around the different agricultural area. And we also show the 7-day forecast to show them the the next 7 days, the weather will change. It's easy for them to manage their weather adjustment for their farmer. And we also show the 2 weeks extremely event probability forecast and the 3 months probability forecast to the farmer. And for the water resources, it's very important in Taiwan. And not only we show the weather pattern, we also show the weather in the reservoir, because it has a lot of reservoir around Taiwan, especially in the winter time. Most of the reservoir cannot receive a lot of the precipitation. So the long-term preparedness is very important. So we provide those information. For example, we provide the everyday forecast and week 1 to week 4, and in the monthly we provide them month 1 to month 6. Those information can show the situation of the reservoir weather condition in the near future. And if, for example, in the Taiwan, after September, the rain season will stop. Okay, so at that time, the monitoring of the precipitation or the reservoir weather conditions are very important. So we cooperate with the Ministry of Economic to develop this kind of information for them. This kind of the warning early process to them. Besides that, we have some kind of the cell phone apps for them. If their threshold greater than the threat value, and we will show on the app for the user to know how to prevent the severe weather or the extremely climate condition occurred. So in my summary, in the response of climate change, the CWA is working in improve the seamless weather and climate service and early warning system. They include everyone helping protect the life, support the community, and build a more sustainable future for the country. Thank you very much. Thank you.
Thank you very much, Director General Liu, for your wonderful presentation. Please return to your seat. 我们谢谢署长为我们带来精彩的分享，有请署长先行回座，谢谢。接下来，让我们邀请到内政部国土管理署徐彦兴副署长。Please welcome Deputy Director General Yan Xinxu, National Land Management Agency from the Ministry of the Interior. 他要分享的主题 he will talk about national land resilience under climate change. 我们掌声欢迎。
Okay, thanks. I'm so honored to hear to talking about our national land management under the climate change. 接下来我可能用中文来跟大家说明一下我们的这个整个简报的相关的事情。They have the translation. Okay. 大家如果都很清楚的事情是，我来自国土管理署，那国土管理署以前叫营建署，它最主要的工作，过去的工作其实在做的其实是基础设施的营造建设及规划、空间规划。那在这个所谓的气候变迁，那我们应该因应什么事情？这大概是我今天想要跟大家表达的事情。那首先，在谈这件事情的时候，其实主办单位给我们2个 keyword， 一个是调适，一个是韧性。好，那我们就先来思考调适这件事情。其实调适这件事情，感觉上是一件事情来了之后，我们要调解及适应。韧性的意思是一件事情来的时候，我们要整个 ideology 就整个意识、整个看法，全部的一些调节的行动，其实是如果从哲学角度，其实蛮冲突的。好，但是也可以看到，这就是当下我们不同价值观、不同思维下，我们可能这2个县市都要做，才能真正的面对气候变迁。好，这大概是首先这个事情。然后刚才那个署长已经讲得很清楚的哈，在台湾面临气候变迁这个部分，在气候这个部分里面有几件事情，尤其 这4件事情。第一件事情就是温度的事情，又高又低。刚才上一个简报已经讲了又高又低的事情。第二个事情是极端的下雨，极端的下雨。然后台湾的特色，想要跟大家讲，台湾特色是不大，然后那个南北很长，东西很短，山高水急，所以极端的下雨，再加上我们人口多，然后城市发展密度高，所以山高水急加上这个那个巨下的这个雨，其实影响非常的大。这个影响相对可能跟欧洲部分地区是不一样的状态。那第3件事情就是这个台风会常常在我们这边的出现，这大家都清楚。第4件事情就是这个海平面的事情，海平面的事情。然后这几件事情面临到我们内政部或我们的国土管理署，我们面临这件事情，其实刚好有3个最近的法律的实施，其实都可以来协助我们做这件事情。第一个大概就是气候变迁因应法，相信待会那个下一位气变署的副署长会讲得很清楚这个部分。第二个部分其实大家也可以知道，而且在台湾非常夯这个议题，就是再生能源法。第3个其实大家一直没有发现，其实是2015年的国土计划法。那国土计划法某种程度就是刚刚讲的这个调适，其实可以协助的。可是如果任性国土计划怎么样去做这个适应，这件事情可能就是我们国土管理署的一个挑战。所以在这样的挑战的部分，我们怎么去调节跟相关的事情？那时间关系我不细说，可能简报上都有的，未来应该是可以提供给大家。我们国土计划法的法里面就有气候变迁的相关的原则、目标、价值都有。这待会我也会用我们目前实施国土计划的这个空间计划的部分，怎么做到相关有关气候变迁的因应的事情。然后在台湾，大家知道空间计划大概几件事情，除了刚刚讲的气候变迁之外，其实我们同时碰见的事情，其实是那个人口的老年化、少子化，再来要碰到的其实是我们的住宅问题，还有我们都市很旧，然后没办法因应很多事情的应变的事情，然后再来，其实大家都知道 COVID-19 的事情，然后另外一件事情是比例来讲，我们开发过的地其实相对是大的。那现在谈气候因应或生态的系统的时候，我们相对挑战也非常的大，非常的大，量大，然后相关的事情也大，所以这几个事情也面临到我们在处理国土计划的时候，同步都要面临，不只是气候变迁，同步怎么样去更智慧的因应，这大概是我们面临的问题。我们就举一个例子，这个例子大概在座如果是在台湾的话，大概很清楚哈。这部分就是我们今年7月碰到一个丹奈斯台风出现的问题。然后其实刚才这个气象署署长其实讲的我们那一套的系统，其实我个人非常引以为豪，就是我们可以在即时就可以看到气候对我们的影响，不管各种的媒体、报纸也好、NINE 也好，这个手机的托播都可以，而且时间一到，像我的手机，只要有任何的暴雨、台风，我马上的讯息都是几百条。然后民间出现了什么事情，我马上讯息也是几百条。好，在这么多的事情，其实我们在这个预判、预测、通知都做到了。可是如果大家知道，以这个为例，大家也知道我们发现了一些问题。那些问题待会我用上一页忘了讲，大家可以看到。我们一个很特色的事情是，我们很少的路径是从我们的西部这样上来，所以也面临我们台南市、嘉义县等地，尤其高雄县的出现的一些问题。然后我们怎么样去处理？为了这件事情，我们要做的很多的事情。然后这件事情其实我们一直在近期，我们就做了一些挑战跟相关的一些规范，在我们的空间使用这个部门。第一件事情其实就是我们怎么样把生态观的都市计划，已经其实在指定到我们台湾省的都市计划的施行细则。简单讲就是台湾省有一些规范，叫地方做一点事。 做有关生态的事情。第二件事情就是我们怎么样的基础设施更可以因应生态也好，还有气候变迁的事情在做。第三个事情其实是我们一些土地使用管制也修了一些法在做这件事情，待会会细说这个部分。然后我们在做这个部分，同时其实我们怎么样让公共的建筑物更有韧性，更有绿建筑的这个能力，还有这个能源的使用的耗能的事情，我们也做了一些挑战。另外一个事情其实是我们也鼓励私有建筑物，那当然是用奖励的方式，奖励容积的方式，让它去做绿建筑或是节能的相关的这样子的开发跟开辟。这当然目前我们的法令上也有这些事情。然后再来在基础设施，我就有讲过，我们用总和治水的角度，是把整个水的系统统合出来之后，再来从生态也好，气候变迁也好去做调节跟调试，然后在这样子的规划下，再总合下去才去做工程。大概是我们从这个角度去做相关的实施的一些方式。另外一件事情，其实是在道路建设，我们也开始去注意到这个生态也好，那个降温也好，还有这个永续也好，防灾也好，都投入了相关的工作再去做这件事情。然后中央是由中央来补助地方，地方来争取预算来做这件事情。在这样的原则，我们往下面去做这样子的道路的相关的这个基础设施的建设，好，大概是从这个角度去做。另外一件事情，其实我们最近也一直在做，这主要除了内政部，其实行政院也一直督促在做，其实就是在很多在灾害时候容易变成孤岛的地方，我们做的一些作为。那首先就诚如刚才的前面的简报，我们用数据、叠图，还有民政系统的回报，去找出了我们可能在灾害面临时候的这些孤岛的社区，把它辨识出来。辨识出来之后，接下来就要做些事情。第一个就是让那孤岛其实的公共，尤其在公共的部分，我们可以用太阳光电跟储能系统协助它，至少在面临这个挑战的时候，断电的时候，它可以得到一起这个基础的这个运作的部分，还可以基础的运作。然后台电公司也协助我们做防灾型的微电网的一些事情，然后最近大家如果知道立法院刚通过的那个韧性条例，我们更进一步要把这个东西推广下去，做得更大、更绵密的部分，至少供给基本的民生、消防、紧急用电，大概可以到14天，用这样子的规范跟原则去做挑战。当然，另外一件事情，这个部分应该已经是我们这个非常厉害的部分，就是在做紧急撤离或这个紧急避难时候的短期的收容的部分。那这个部分的运作跟相关东西，我们到目前大概1天都可以。我们只要判短信出来，它其实有危机的时候，其实我们就已经建设完成了。然后如果真的临时发生的话，我们其实也是在1天内可以到达，也可以做完成。所以我们这个东西已经变成一个我们非常熟悉的一个运作的方式。好，另外一个就是移动式的发电机跟储能柜跟卫生系统，这个部分我们也可以标准化，也随时可以送到这个相关的地方。这大概是我们韧性的相关的事情做，还有卫浴，还有气候这个机械通风设备系统。好，这些事情在面临这个灾害的时候的一些动作跟设备，其实我们这个已经都布建的差不多了。另外其实就是无线网络跟通信系统。然后大家都知道，现在至少有手机，如果真的断到电，你在市话的电话里面没办法通的时候，我们其实可以用各种这个低轨卫星也好，这个通讯车的到达也好，可以去补足这样的事情。这几个事情都已经我们现在正在做，也做得也不错。那刚刚谈国土计划，那其实国土计划到目前22个县市都已经送到中央的，我们已经审了16个县市的国土计划，然后大家的国土计划都有气候变迁专章。然后我就举例好了，第一个当然就是从用这个，第一个就是我们的这个风险的部分的调节，然后就是刚才讲的，台湾在这样的目前有关气候变迁的图资其实是算完整的哈。好，做一些叠图跟调节之后，接下来做的事情就是这样子的部分，我怎么样在这 概念上跟空间上怎么安排这部分，它就必须在国土计划里面提出来。提出来之后，就要做所谓土地使用规划的一些原则的部分的拟定。这是我们的台南市。好，很有趣的时候，大家可以看到左边这张图，这张图有没有看到？在台南市，如果认这句叠图，这次风灾造成淹水的地方，我们早就辨识出来了。可很可惜的是，它的土地使用跟因应跟infrastructure还没到位，因为这只是个规划。好，这只是个规划，很可惜做。你看，其实这个程序其实应该有做到，但是我们剩下就是下一步就是这个事情的落实的部分。好，那这是这个桃园的部分，我就不细说，同样也是这样做。然后这是那个台东的部分，也做了相关的这样子的气候变迁因应，所以这样子的话，至少在各县市、各地方政府面临气候变迁，他发现它的风险因子之后，做的一些回应、回报，还有土地使用的因应的部分，这个部分以及在这一波的国土计划已经做得差不多了。好，那当然它只是有原则，接下来就是计划实施的部分的挑战。可是想跟大家报告说，那为什么如果从这样的角度，我们也做了这么密度的工作？为什么还有丹纳斯台风的出现？然后出现之后，这个民意为什么还是这样子的反弹？这值得我们去思考。这也就是我刚才一开始想跟大家说明一件事情：是韧性是一个新的意识形态的看法，新的观念。所以这是一个典范的移转。然后刚才第一份简报其实也很清楚，这个典范移转在的其实是每一个人民。不仅是技术，不仅是政策，不仅是预算到位，是每个人民面对气候变迁的那样的生活态度。好，那是一个我所谓的典范移转的这样子。好，那既然是个典范移转，我们就必须处理很多的事情。当然，在政府部门第一要做的事情就是我们怎么思考这个部分。那我常常跟我们同仁分享一件事情，你至少要跟我盘点出国土计划法跟其他法它之间的关系和合作的部分，这部分当然是接下来我们的挑战哈。然后下一波的国土计划，好，我们希望大家继续支持我们国土计划可以实施。好，现在那国土计划下一波国土计划就要面临这样的挑战，去做更进一步的整合、调整跟协同合作，这是部门间的合作，这当然是我们想表达的事情。然后再来的事情就是我们要做这件事情，其实还碰到一些问题。第一个问题就是水平的整合。垂直的第二个问题是垂直的整合都不足。第三个问题其实是缺少地方的实践或地方的这个整体运作的那样子的，缺少这个相互的变成一个伙伴关系，或变成一个 A team 的这件事情还是有点缺乏的。然后另外一件事情就是我刚刚讲的，人民自认为这个是韧性。好，其实人民在行动的时候，其实给我们的回应其实还不是韧性哦。还是建设，给钱。那这需要陪伴，这需要观念，这需要教育，好，等等事情都在这里面去做的。所以面临这个东西，我们就必须很努力去做这件事情。另外一件事情，其实大家也知道，整体的建设工程跟规划，还要连专业者都必须有 NBS 的看法，好，自然解放的看法跟策略，那才能做出这样子的规划。这也是我们未来极端要挑战的事情。好，然后做这件事情。然后谈到气候变迁的这个韧性的部分，我们要做几个事情。好，第一个事情，这个我们已经辨识出来，这是国土计划，我们现在已经有3支计划在我们署里面，3支计划在处理的。第一个事情当然就是热的这个温度的影响，好，高温的影响。第二个部分就是那个水灾的影响。第三个部分其实是新的建筑物我们怎么样去因应的这个事情，我们也正在修相关的建筑技术规则，其实有一部分已经修完了哈。这部分我们今天时间关系我不细讲这部分正在做这件事情，但是还是不足的，所以我们有几个策略正在推动，这也大概是从前2年才做初步的盘整，然后现在才开始进行一些深水区的一些那个讨论跟相关的处理哈。那主要处理这个事情，其实就是要让这件事，我们刚才讲的这些事情，其实是真的可以实施跟推动。好，这大概是我们 在这个国土管理的部分希望这样子的去整合跟推动的部分。然后这个部分第一件事情，其实刚刚都谈过了，好，这个东西是这几个原则怎么样纳到我们下一阶段的各县市的国土计划，还有下一阶段我们在各部门在做它空间计划的时候的原则跟准则。不过我讲良心话，刚刚也在下面跟这个副署长在谈的时候，我也发现一件问题，在空间计划在做气候变迁或碳的这个整合的事情，其实我们缺乏更实证的方法论。当然大家也会聊这个方法论要不要马上就跟国际接轨等等的事情啊。大概这个部分的整合跟辩论跟简单讲就投资，我觉得还不足。所以这个要变成可以这个往前走很远的部分，我觉得接下来挑战大概是这个。但是我已经辨识出来这几件事情，我们必须往前推跟相关的事情。为了这件事情，刚才也谈了水平的整合、垂直整合不太够，所以我们从去年年底就开始跟部门，不管地方政府、不管 NGO、不管各大学、不管那个跨部门的部分，我们都一直在做这种。这个平台的建立跟平台的对话，希望从这个角度找到共同可以做事情的一个策略跟方法。好，这一步我们也正在做。第二个部分就是这些整合怎么样入到各自的部门计划。好，这个部分也是接下来的挑战跟我们想要往前面做的事情。好，另外一件事情其实更重要，其实是真正到第一线在做工程的人、设计的人、规划的人。工程的人、管理的人跟地方政府这些人，他为什么要这样做？他为什么要做友善气候、友善这个近邻的工作？所以接下来我们想要做的工作跟挑战，大概就是希望强化大家对这件事情的感知，可是要制造那个氛围。如果没有制造那个氛围，它是很难去做的。你想看看，在第一线突然想做，然后他的科长跟他讲说，我只有100万。或是这个科长想做，然后可是他的建筑师说，这样做花很多时间，那没办法达到，等等事情就一堆问题出来。所以那个氛围其实需要打造的部分，这也需要很多这种设计指导、设计解决就是design solution的这些方法论或design solution的方式来创造这样子的氛围，然后往前走。好，这第一步我们可以做。第二步其实，我们谈社区的 empowerment， 一句话很简单，但社区为什么进来？我觉得台南或嘉义这次风灾去面临的东西，其实告诉我们，我们任性的这样子的社区的活动的部分，还是太交代式，或是指导式，或指引式，而不是一起创造，变成一个身体记忆的工作。所以我们接下来的形式可能要创造一些让地方的韧性自我建立的这样子的过程，所以是以市民的、人民的为核心的一些方式跟方法来去做这件事情。那过去其实我们也实践了蛮多这个方法论跟人才，可这个人才可能都不在做气候变迁。可能在做这个社区营造，可能在做地方创生，可能在做农再，农业的再生的事情，怎么样整合，可能是下一阶段我们可以思考的挑战的部分。然后跟大家报告，其实现在的国土计划，其实还有一支的法令还告诉我们，还给我们一个新的政策机制，叫做乡村规划。过去计划做到很细的部分，只有都市计划，所以我们也借由这个刚刚讲的这样子的策略，跟结合我们的乡村规划，才能让乡村地区它的韧性是得到被整合跟自我体验，然后变成自我组织，然后可以 run 的事情，而不是只是政府的机器的一环。好，这当然是我们另外一个想要的表达的事情跟合作的事情。那另外一件事情其实是大家的认同，所以大家认同就必须集合大家的认同的部分。我们常常办展览，或是办成果展，或是办会议的相关事情，其实比较少。其实是我们在一起打造一个理解一件事情，然后得到典范移转的一些态度跟自我的组织的一个过程。所以这样子的过程，其实我们只要把我们很多的展览或很多的 这个博览会也好的事情，做这个心态的调整，其实就很容易往前面走，然后取得的其实是公民的认同，而不只是少数社群自以为我们这样做很高级的等可能，而是大家自我的认同的这部分。那这部分某种程度是一个很辛苦的工作，但我觉得台湾这几年，大家如果去看文化部门的什么文博会啊，相关事情也做得都很好，就只要把他们借来，就可以操作了。好，那预算其实还不是最大的问题，可能只是这个整合力跟自我的运作可以往前走。然后我们做规划了，一定也是这样子，因为规划太多太复杂的事情，一个地方空间事务太多了，唯独用这种方式才能取得认同，往前推进的部分。然后所以从这个角度，你可以看到怎么样就是我们政策怎么样落实的挑战。然后第二个事情是我们在这个刚才其实署长也有报告跟大家分享，就是在这个气候科学跟实践里面，那这个中间的 gap 怎么去填列？其实我现在发现这件事情，其实我们做的已经以我所知道各国，其实我们做的已经很不错。可是第三块，其实我觉得是接下来挑战，也是刚才署长有稍微在讲的事情，其实就是数位孪生的事情。因为你要跟人民沟通，你要让他看得到结果，不仅是看到这些 index 这些指标或这些风险值，而是这个结果效果跟我之间的关系。所以这样子的部分，其实接下来挑战可能是这个部分的整合。而这些事情数据都在，可是都在各部会。那可是也不可能各部会各自做各自的，这样子其实老百姓只要一个讯息。所以这样子的状况之下，怎么整合，或许是下一步我们可能要做的挑战。另外一个事情其实就很清楚，就是这个钱在哪里，人才在哪里这部分也是我们下一步要挑战的部分的事情然后最后一章跟大家分享，如果从这样的角度，我们其实面临气候变迁，在空间治理或空间规划的部分，我们怎么样调适，我们怎样变成真正的一个韧性社会。从一个不是很任性的任性是真的可以 capacity 很多的风险的这样子的心态的一个社会，其实路还有点难，路还有点长。但我的观点跟我的看法，其实是相关的投资或相关的事物，或是要组成这些事情的元件都到位了。接下来是怎么跟心灵沟通，然后变成从一个功能的事情functional 的事情，变成一个 society 的一个过程。所以从这个角度，就是要用典范移转的态度去看这些的事情。第二个事情就是怎么样让政府从一个政策执行变成一个治理的一个方式。第三个部分其实就是怎么样跟地方变成一个兄弟关系了这个事情其实说简单但蛮挑战的。我过去工作的2/3是在地方政府，其实很清楚中央跟地方虽然看似兄弟，其实常常没办法一起合作。那只要态度跟资源的适当的安排，我觉得这机会就是非常的大。那另外一件事情，希望我们的每个投资都为了我们的未来跟下个世代。好，谢谢大家。
我们谢谢徐副署长充满热情的分享，我们请副署长回座，非常感谢。接下来呢，让我们邀请到下一位讲者，环境部气候变迁署徐旭成副署长。Please welcome our next speaker, Deputy Director General Xu Chengxu, Climate Change Administration, Ministry of Environment. 他要分享的主题 ，He will talk about climate adaptation, governance and action in Taiwan. 掌声欢迎。
几位外国来的贵宾，还有吕署长。那我是接续在徐副署长后面的徐副署长。那接续刚才徐副署长所谈的一个非常重要的关键，就是不管在土地使用规划的层次，或者是我们谈调适，其实我们正在面临所谓的 paradigm shift， 就是典范的转移这件事情。那其实我也还蛮喜欢用部长谈的一个 案例啊，就是说一个比喻啊，就是说我们现在面对那么多的极端灾害，就像我们得了感冒、流感，这可能会致命，所以你要马上去因应它。但是人的身上常常会有很多的慢性病，就像地球其实受整个气候变迁的冲击，其实越来越严重。所以中长期的调适，相对于气候变迁这件事情，可能甚至对下一个世代来讲更重要。所以其实我们在推动台湾的调适，也正面临的我们怎么样从我们如果把过去防灾体系比较归类来于所谓的反应式调适这件事情来讲，那中长期其实我们正在面临所谓的典范的转移，怎么样从反应式的调适变成转型式的调适？我想这个是我今天谈的一个很重要的核心哦。那待会我会作为这个 session 的最后一个讲者，其实某种程度我也在回应台湾大概在调适这件事情上，其实我们从2010年开始调适这个概念，其实早上大概主席有特别谈到，在国际调适历程 COP16 的坎昆协议，其实是这一个非常重要的关键。那台湾其实也是在坎昆会议之后，把调适这个概念引入台湾，那个时候大概2010年，所以到现在为止，你会发现大概有15年的时间，15年的时间，所以我们当然也面临了所谓的典范转移的过程。那待会我会把我的报告里面大概分成4个段落，那我会把过去的这15年分成3个阶段去做一定程度，大概因为时间不长，我会很快去做 review。这中间其实你就会看出来一些刚好呼应的，其实是我们3期现在的 NAP 国家调适计划。那更重要的就是我们台湾的调适大概要往哪个方向走？我想这个是可能我在报告的最后面会跟大家谈的。那当然，其实大家谈了非常多这几年来的极端天气事件，尤其是高温这件事情，因为2023年、2024年大概是人类有历史观测以来的创新高的高温。那如果以单一年度来讲，其实已经超过了我们想要力守那个1.5度C。那其实极端天气事件其实也是频率非常非常的高啊。今年度大家最感受到其实是热这件事情，从年初加州的森林大火，一直到这几个月，我们应该新闻上都会看到欧洲的热浪。其实台湾大家其实早上部长有特别谈我们现在在针对40度这个情境，其实在做模拟。那因为38度对我们来讲发生频率是非常非常高。最近因为我们跟气象署有一系列的合作，也就是说他们会固定发布了温度的即时预警。那大家知道，其实2个礼拜前，其实内湖出现过2个红灯。2个红灯的意思就是连续4天38度。隔了1个礼拜，新北市的五股出现了3颗红灯。3个红灯的意思大家都知道，是连续5天38度。也就是说，其实从历史上来讲，台湾出现过39.7度，如果以45度来讲，其实是已经逼近40度的高温。那所以部长他早上特别谈40度这件事情，可能在未来的几年内一定就会发生。那台湾其实刚才大概都非常提到我们今年非常印象深刻的丹尼斯台风可是我想特别讲的就是说，台风这件事情其实来与不来，我们都非常困扰。为什么我特别这样讲？来的情况大家非常了解，这不用我再多说，造成非常严重的灾害。不来，大家如果还记忆犹新，我们在疫情最严重的那几年，台风是不是曾经3年没有侵袭过台湾？从2020年到2022年，那时候发生什么事情？大家还记不记得一个名词叫做100年大旱？100年大旱，所以台风来与不来，其实对我们的因应冲击大概都非常困难。为什么？因为台风所带来的雨量，从过去大概才占台湾总雨量的15%，现在已经接近30%了。这样你就可以理解为什么台风没有侵袭台湾，其实我们在水资源调度上也会非常困扰。防灾的体系 其实因为台湾经历过非常多大规模的灾害，其实从1996年我不知道，可能我这个年纪的人大概还记得赫伯台风。赫伯台风重新定义了土石流这件事情，大家从那个之后才意识到土石流。1999年9.1大地震，一直到2009年的莫拉克风灾，其实台湾的防救灾体系建立了一定程度的一个完整性。所以现在我们大概面对这种灾害型的应变刚才就特别提到，就是刚才徐副长，我刚才都因为我们一直在聊这件事情，其实就呼应到他刚才有谈到哲学上的名词就是调适跟韧性这2个字。过去其实 resilience 我们开始在谈这件事的，其实我们比较少用韧性，我们用了一个名词叫做什么？回复力。回复力，其实这个大概你就可以理解。其实韧性 resilience 这个字，它最重要的内涵其实跟调适是呼应的。调适我们谈的是什么？灾害一定会发生，气候变迁会持续性的做冲击。我们当然事前可以做一些政策上的处理事前的准备，但更最重要的其实是我们不怕灾害来。灾害来之后，我们那个回复的力量，我们很快恢复正常。这个其实是韧性或者是我们调适的一个非常重要的意涵。那台湾经历过这个过程之中，其实防救灾体系，我个人认为其实有一定程度非常完整，有一定程度完整性。即使我们面对每年这么激烈的风灾，但是中长期的调适其实还需要进一步做一个更完整的一个整合。那温度这件事情，大概我开头也特别有谈到，以全世界来讲，其实2023年、2024年，大概全世界温度都创新高。那根据我们目前的观测，今年可能不会再创新高，因为去年太高，基期太高。但是其实今年的高温情况，大家也非常了解。那根据 TCCIP 的一个模拟，如果以这个趋势不改变的话，其实台湾其实冬天会越来越短。夏天会越来越长，可能到2065年的时候，那个时候就是没有冬天的这样的情况，而夏天可能是持续半年。这个就呼应我开始所谈的典范转移这件事情，就是说，过去其实我们针对极端的，不管是温度或者是极端天气事件来讲，我们大概会比较，因为毕竟生命财产的安全要及时性去做因应，所以会比较集中在我们所谓的反应式调适，也就是短期防灾的作为。那长期其实怎么样透过转型式的调适？其实转型式调适，刚才土地使用部分徐副组长谈的，其实就是转型式的调适。规划是一个非常重要的武器跟工具，怎么样透过国土规划或都市规划的层次，做一些彻底性的土地使用的转型，来回应气候变迁这件事情，其实就是转型式的调适。那另外调适一个非常重要的观念，其实就是在积极性的创新，短期防灾，长期积极性的创新，包括我们的农业部门，包括我们的产业部门，怎么样把这种逆境变成一个新的发展机会，这个可能才是调适的一个非常重要的意义。那怎么样从短期性的反应式的防灾变成长期性的调适，可能就是未来我们非常重要的一个发展方向。那这张图其实是去年 COP29 其实 UNFCCC 它发表了一本 paper 叫做《调适30年》，它从1994年联合国气候变迁纲要公约一直到去年2024年，它整理了调适30年发生什么事情。但是其实你细看内容以后，你会发现调适只有20年，因为前10年你会发现集中在 mitigation 的讨论。那当时候其实他们知道调适的重要性，但是他们担心利分而落，所以做 mitigation 其实就非常困难了。如果要这样调适，其实资源会有一定程度的困难。所以一直到2005年，其实你会发现，大概调适的架构，他们才开始了解到调适的重要性，开始去做积极性的推动，所以出现了 APF 这种 Adaptation Policy Framework 这样的讨论，一直到2010年，其实这个是非常重要的关键。早上主席也特别谈到坎昆协议，因为他成立了调适委员会，开始成立了所谓的绿色气候基金那有一些在有关 因应气候变迁调适上面的投资要去做进一步的处理。那从那个时候开始，一直到2015年的巴黎协议，大致上才确定了调适跟减缓并重这件事情。那呼应到台湾，其实也是在那个时机点，在2010年坎昆协议之后，我们把调适的这个概念引入台湾，这个算是台湾开始起始推动调适这件事情。所以，如果以这个时间点来看，我刚才有特别提到，我分成几个阶段。第一个时间点的确就是调适引入台湾，然后由经建会来做整体性的推动，因为当时他们跟总统去做报告，除了认为说台湾除了谈减人减碳、谈冷气要开几度这件事情以外，调适必须要开始去做推动。所以第一个时期其实很重要的一部分就是他们在做一些调适这个 scope， 到底台湾的调适是什么？调适这件事情其实是因地制宜的，每个地区因应气候变迁的冲击不同，它所做的调适因应其实是不同的。那到底台湾的调适应该是界定在什么样的范围？这个可能是第一阶段他们来处理的问题。那第二阶段其实是在温管法的修法之后。大家知道，当时候温管法修法，其实在最后一刻，在立法院把调适这个名词放在温管法。其实调适放在温管法，感觉就怪怪的。调适放在温室气体减量管理法，但是在立法院修法的时候，正式把这个名词放到调适，因为那个时候知道国际上的趋势，所以在那个之后，由环保署接下这个重任，开始去推动气候变迁调适的这个工作。那我们在那个第二个阶段，其实很重要的部分，我们界定就是能力建构这件事情，其实在调适扮演非常重要的角色。然后随着立法上的建立，我们终于有了2023年，我们有气候变迁因应法，开始在这个法令里面减缓跟调适并重。所以第三个时期，我们开始进入了在法治架构之下，我们有法定的中央跟地方的调适计划，正式进入法令架构的部分。然后之后，其实现在的第3期的 NAP 正在执行当中，但是我们从今年开始已经启动了我们新一期的调适计划，也就是116到119年的调适计划。这个时候，其实有些重要的议题就非常重要。第一个就是我们今天其实花很多时间谈的复合性风险这件事情，调适必须要有所因应。另外一个部分就是我刚才一直提到转型式调适这件事情的精神，其实是一定是需要纳在我们未来调适方案或计划里面。OK， 好，那接下来我大概就很快的review 我们前面3个过程。那第一个过程其实刚才有特别提到，就是调适推动之初怎么去界定调适的范畴这件事情，其实是非常重要的。所以当时候大概经监会在过去研究的一些基础下，包括国科会、包括农业部、包括经济部，其实他们在因应气候变迁事情上面，其实走得比较前面。怎么样把各部会的既有的研究跟力量做一个整合，其实是这个第一阶段非常重要的部分。所以他们发布了整个的调适的 policy guideline， 其实也是整个的台湾的 APF 这样子的一个政策。那它界定的调适有8个领域，这个8个领域其实也界定了这10几年来台湾的调适到底要做什么。但是我们回过头来去看这个8个领域其实这隐含了其中非常有趣的部分，因为当时我参与了这个部分的讨论。联合国的 APF 其实只建议了5个领域，所以有3个领域其实是台湾自己新增加的。第一个，灾害，这可以理解吧？台湾在高度风险、脆弱性高的地方，所以台湾谈调适必须从灾害开始谈起。第二个就是刚才谈的土地使用。其实以土地使用的角度去谈调适，这在国际上其实台湾算跑得蛮前面的。那为什么会特别从土地使用角度谈调适？其实刚才徐副署长谈的非常多，任何调适的因应，最终都会回到土地这个载体上面去做回应，而且就是任何的调适作为，你都必须落实在土地使用上面了。所以土地使用必须要有所回应。另外一个部分就是台湾其实80%的人口在都市范围， 都市是高度脆弱性的一个因应气候变迁的一个载体。都市规划怎么样去做具体性的回应，其实在调适的计划里面非常非常重要。这个其实是台湾自己增加。另外第三个，台湾增加了一个能源供给及产业。台湾的能源有高度脆弱性，也同样受气候变迁的冲击。产业其实代表的就是调适的积极创新这件事情。所以其实这3个领域当时候在界定的时候，其实是超过联合国的 APF 的范畴之下去做界定啊。其实那个时候界定之后，大概也影响到未来这10几年台湾在推动调适的一个很重要的一个方向。那这个80领域下就界定了第一期的NAP， 台湾的 NAP 从2013年开始到2017年。那我们 review 一下第一个阶段，你会发现其实因为是经建会在做推动，他们尝试了去整合调适相关的部会跟资源，这点非常重要。那我们也慢慢的从过去从防救灾为主的体系，慢慢进入到所谓的灾前的预防跟灾后的迅速恢复正常的韧性这样的一个概念。但是另外就是说，能力建构的这个部分，其实基本上还不是非常稳定，甚至我可以说，当时候参与调适计划的人，现在其实都不在位置上。那等于能力建构的过程非常重要。另外一个其实比较大的一个问题，其实在法制上没有去做具体性的回应。所以进入了第2个阶段之后，由环保署开始，一直到环境部去接手调适的推动，我们就进入了一个以能力建构这种 concept 为主的调适基础这样子一个计划。所以其实第一个，我们开始去整合。我们刚才讲过，第1期计划因为很多都没有法定组织、法定架构，甚至没有办法依法去做调适，所以后来第一件事情在第2阶段里面就整合相关的法令。所以刚才其实包括国土署后来推动了国土3法。为什么国土计划法里面有调适专篇这件事情？所有的国土计划都要做调适，其实是在那个时代，我们认为其实国土计划法必须优先把调适的精神纳入。那另外，其实你会发现水利法也是净流分担、出流管制，其实也是在那个架构之下去做推动。怎么样从过去可能第2线，他们现在定义上堤防治水这件事情，其实是在治水的第1、2线。第1线其实要透过整个土地使用的规划，把它净流分担跟出流管制纳到都市的发展里面，那才不会让后续的相关投资来不及去做因应。那另外就是怎么样把调适金融这样子的概念放在农保法以及相关的法令里面。那另外就是能力建构在第2期的计划里面变成一个除了8个领域以外上面的一个很重要的专章，所以特别界定了能力建构这个地方的范畴，包括细节我大概没有办法讲，包括我刚才讲的法令的部分的完整性以及大概怎么样有一些新的激发一些新的产业以及大概调适金融，还有各方面人才培育的部分。那另外也包括了整个整体性的能力建构该做的是风险评估的一个推动，那以及包括跟科学研究的串联怎么样让我们的调适规划能够在风险评估的基础之上去做进一步的一个推动。那另外其实也开始了在现有的科学研究上面跟国科会的 TCCIP 的平台去做串联所以我们开始包括 TCCIP 也提出了台湾的未来的气候变迁情境，甚至进一步在后续的计划里面开始去推我们所谓的调适，就是各个部门做调适要运用的气候变迁情境是什么。那所以第2个阶段大概你会发现渐渐的朝向法制化去做推动，但是还不足的，我觉得在于因地制宜、地方为主的地方参与这个部分。那另外 NBS 的这个概念慢慢的引入，但是还在各个调适计划里面，其实还看不到那么明显的发展。所以进入到第3个阶段以后，就是比较完整的，我们是在气候法的架构之下去推调适这件事情。所以进入了我们第3阶段的法治体系下的调适。 所以在气候法的部分，大概时间不允许我做很快的做阐述，包括我们除了2050近零碳排这件事情纳到气候法里面，更重要的其实我们有调适专章明定中央或地方或是科研组织跟实际上因应气候变迁的易受冲击领域的部会要怎么样去做因应。那这个是调适专章的一个相关内容麻烦大家请参阅。我希望留点时间谈未来的那个部分。那另外，调适是一个跨部门的整合，所以以环境部其实跟我们的国发会就环境治理、调适治理的部分，我们建立了平台。但科研的部分，包括整个环境部，可能包括国环院，其实跟国科会大概建立了科研研究的平台那透过这个平台的串联，来整合各个部门的，包括调适治理跟科学研究。那这个是第3期的调适计划的一个架构，你会发现，其实灾害不见了，灾害不见，其实它不是不见。最近其实我们在回应这件事情其实它不是不见，而是灾害体系，因为我刚才讲过程的发展，其实以台湾来讲，相对制度性是非常完备的。我们也有灾害防救法，我们有固有的灾害体系。那当时候放在调适这个部分，其实相对来讲会集中在科学研究。那它不代表了灾防的完整要做的事情。所以后来大概在国科会以及行政院灾防办的建议之下，希望回归到灾防体系、灾防法的架构上去做推动，就不特别放在调适计划里面。那另外这一期里面你会发现能力建构会有个专篇特别谈这件事情。OK， 好，那第3期的计划里面，其实大致上已经在法令的架构之下去推中央跟地方的调适，所以最后的时间，其实我想跟大家谈一下台湾的调适要往哪一个方向走。那国际上的一个趋势其实也明白告诉我们，大概从巴黎协议以后，你会发现从 COP29 到今年的 COP30， 其实调适的部分着力还蛮多的。COP29 大概界定了调适的范围大约是什么，甚至认为韧性基金到底要往哪个方向投资，其实请各国提出说你要做的调适，你要提的调适指标是什么，所以在界定 GGE 这件事情。那 COP28 其实提出了阿联的一个调适韧性架构，其实大致上也界定了说调适包括哪些范畴，而你应该怎么样去做规划推动。今年其实一个很重要的关键在于，我们刚才讲了 GGA 这件事情，因为各国提了大概7000个指标，因为大家都想要争取资金那 UNFCCC 希望进一步把这个7000个指标浓缩变成100个，所以这个是今年 COP30 的一个非常重要的任务就是界定清楚调适指标这件事情是什么。而这个就是调适的韧性架构，其实在于重点我们发现其实跟过去有些不一样，一个是它特别强调 ecosystem 这件事情，ecosystem 独立出来，希望我们在做调适不要危害到 ecosystem， 甚至某种程度，其实 NBS 也就是让自然环境来帮助我们来做因应调适。那另外一个部分，其实我觉得蛮重要的，其实是 culture。culture 这个大概是这个韧性架构的一个非常重要的亮点，就是过去其实比较没有从文化的角度去谈调适，但是包括硬体历史建物，其实受气候变迁的冲击非常大包括文化的传承，其实也受气候变迁的冲击非常大。所以今年其实我们开始新一期的调适计划，我们又做了某种程度的调整，就是我们把农业生产跟 ecosystem 独立出来。其实这个大概本来就是不同面向，那也在农业部的积极推动之下，希望独立。那另外就是海洋与海岸，把海洋特别拉到海岸之上其实也要呼应台湾作为一个海洋国家，在调适在海洋这个部分的积极作为。而文化领域，其实我们当然希望它可以独立是一个领域，但是因为是初期性的推动，目前我们还是放在独立使用的部门里面。那另外，其实我想另外一个重要的议题其实就是高温那高温这个议题，我们同步刚好 我们调试组的组长在另外一个场，只有详细谈调试，大家有兴趣也可以回去看那个直播。大概这是今年夏天我们非常重要的一些政策，就针对台湾高温这件事情。早上其实部长也有分享我们的 Cooler Map， 其实不只是 Cooler Map， 今年其实我们也用准灾害的角度跟气象署一起合作，怎么样针对高安的及时应变这件事情。所以我刚才有特别提到，我们2周前内湖出现2颗红灯。1周前一个多礼拜前，五股出现3颗红灯。其实我们在当天，在我们叫第一 day 2 day 的2天48小时之前，气象署给我们一些资讯的时候，其实我们就开始做一些演练准备的工作，去提醒地方政府跟中央的怎么样去做积极性的配合。所以我们今年其实透过一系列的行动，我们成立了抗高温联盟。希望整合公司部门的力量，尤其是民间的活力这件事情，针对高温的脆弱族群，我们怎么样提供高温的服务那最后面，其实我想要谈一下，就是复合型风险这个议题，这个也会是我们未来台湾调试的一个非常重要的重点时间到，再给我3分钟的时间，我把这个部分大概告一段落。那复合性的风险其实包括复杂，或者是复合，甚至是所谓连贯性的风险。我举一个过去其实大家熟悉的 Sandy 台风的例子，在美国东岸，其实它主要的风险是什么？是暴潮，飓风带来暴潮，但是它其实相对夹带了包括 Hurricane 所带来的极端强降雨。那另外就是长期的海平面上升这件事情，这个复合性的风险。整合在一起，才导致了这个Sandy台风对整个美国东岸大规模的破坏。那另外一个例子，其实是我们可以看到加州野火。但是加州野火在2017年发生的那一次，其实又特别的奇怪，就是它不只是野火，而夹带野火之后夹带了一系列的暴雨。所以野火造成了土壤的抓地力不好，对水资源的抓地力减弱的情况之下，一系列暴雨就造成了后来土石流的灾害。等于说，它先发生野火，后来又导致了后面的土石流灾害。那这样子的情况，其实在台湾的案例里面，其实也非常常见。我们刚才大概几个讲者都有特别去分享。那而台湾大概有73% 的土地，其实都暴露在这种不止一种的风险的一个状况之下。所以你会发现只要我们的雨下到持续到一定的程度，累积到一定程度，不管下在哪里，其实都会累积进一步的复合型灾害。那我们最近其实在跟 NCDR 一起合作探讨，就是风险评估已经非常困难了，但是复合性风险评估那更是难上加难。那怎么样透过一些方法学的建立，让我们可以因应复合性风险这件事情？所以它以这一次台风造成很严重的西南地区来为例，它考虑了包括这样子的一个极端的台风事件，加上海平面上升这种双重的因素，去模拟可能导致的气候风险是什么，怎么样去做及时性的因应。那另外就是科学研究的部分也得持续做了整合去推动。最后其实我以这张图，这个是最近其实刚好我有一个访问，他在问我说，他要我用3个字去谈调适我就做了一下思考这就是我给了3个字的答案。第一个字是整合。调适牵涉到各个部门的冲击，怎么样中央跟地方的资源去整合？调适的跨部门需要 synergy， 调适跟近邻这件事情需要 co-benefit。整合这件事情，其实在调适的工作里面非常非常重要。大家个别单打独斗，每个单位个别去努力，其实达不到所谓的中效。第二件事情其实是 priority， 优先顺序。你到底以整个国家或者一个城市，你的 hotspot 是什么？你要优先去做调适的优先领域是什么？ 在资源跟时间的有限上，你必须要做必要的 priority 的选择，才有办法达到一定的程度的效果。第3个给的字其实就是转型。我们讲近邻转型，近邻是目标，转型才是关键，调适也是如此。怎么样透过积极性的转型，在过去防灾的积极下，透过一些创新的研发，我们未来可能包括部长所推动的绿色成长基金，甚至我们的碳费，其实有很大的一个部分，其实是在鼓励包括减缓跟调适的积极创新。OK， 以上大概就是我对台湾推动调适的一个整个过程的一些回顾跟我的一些 comment。好，谢谢大家，谢谢。
我们掌声谢谢徐副署长为我们带来精彩的分享。先请副署长回座。我们可以理解气候变迁这个议题真的是攸关所有人。那所以呢，因为有这样子的急迫性，我们今天也透过国际的研讨会，希望能够跟大家集思广益，一起找到好的解方。So, ladies and gentlemen, now we're going to move on to the panel discussion. 接下来我们将进行到座谈的讨论。那么也提醒现场的贵宾，欢迎大家待会儿可以举手提问，我们现场也有专业的口译老师可以帮助大家来进行翻译，所以欢迎大家可以用中文或者是英文来提问。也提醒现场的贵宾，您在您的座椅旁边的把手打开会有麦克风，不是每一个座椅都有，您可以看一下，通常是2个座椅共用一个，所以如果您要发问的话，麻烦请把座椅的这个旁边的手把盖子打开，就可以看到麦克风，打开按钮就可以开始发言。Ladies and gentlemen, for the panel discussion, now we're going to have some time for discussion. You can open up the arm set and also you can find a microphone inside. Turn on the microphone and you'll be able to speak. So feel free to raise your questions or comments in English or Chinese. 接下来就让我们邀请本场次的讲者 We would like to welcome back to the stage Chairman Jai Chu Choi, Dr. Juha-Pekka Japola. 我们邀请吕国成署长、徐彦兴副署长以及徐旭成副署长回到舞台上就座。那本场次我们也非常荣幸邀请到主持人国家环境研究院吴月春副院长来到舞台。And now we welcome our moderator 吴月春 Vice President of NERA。好，我们有请贵宾在舞台上就座。So please take your seat on the stage。来，我们帮忙引导一下，谢谢。All right， 好，我们还有一位贵宾，来，吕署长先离开，是不是？好，没有关系，那我们时间就交给主持人，有请。
好，首先非常谢谢各位精彩的演讲。那时间的关系我们就不多美言。那是不是请各位对于今天上午跟下午的演讲，如果需要再次跟我们这些讲者交流的部分，就请各位不要客气啊，请用中文就可以，我们有非常专业的翻译，然后各位就不用担心。好，不晓得各位有没有什么 any question？
机会难得，请问现场有没有任何的贵宾？来这边有，来这边请。来，您的把手旁边有麦克风吗？来，可以看一下。来，请发言，谢谢。请。
各位专家学者们，大家好。一个简单的问题想问Dr. Japola。The EU provides examples of cross-national collaboration and institutional frameworks. How should countries design disaster risk governance systems to enhance climate resilience? Maybe, for example, for the severe wildfire last month. Thank you.
Thank you very much for your question. Actually, I missed the first part of your question. If you don't mind, do you repeat the first part of your question, please?
您的问题的第一部分，可不可以请您再重复一次？谢谢。
我的第一个问题是要问说，各国在设计灾害风险制度上面有什么比较优先的项目？谢谢。
what are the priorities when it comes to the design of the disaster prevention system? Please.
This question is for Dr. Yapola. Sorry.
But I think we both can answer that because you also have a significant experience from diplomatic domain. But from an EU perspective, first of all, it's not easy naturally because countries tend to have different opinions what is a priority. Like a simple perspective that's south of Europe, wildfires, heat waves, droughts. North of Europe, not so much disasters because it's very calm. Maybe floods due to melting snow or something like that. But I'd say the same that has been mentioned, I think, in all of the presentations thus far, that it's more about communication and translating between each other, agreeing with the community, because, of course, the EU is the same to its member states as the central government is here to municipalities. That not much will happen if all sides don't agree, all sides do not communicate with each other, because, I mean, if you try to force from a high level that all of Europe should do the same way, or all the countries should do the same way, it's not going to work because they will not agree with it. We might put it on paper that, yeah, this is it, but they might not do the capacity building, the science translation, and so on. So I say the same as was mentioned multiple times, that communication with municipalities, with the communities, and translating the science properly and talking with them. I don't remember who said it, but it was very well put that we have all the tools and means and mechanisms in place. We just need to get everybody on board with it. So that would be my short answer about it. But, I mean, everybody has a different priority. Every country has a different priority, and changes per the years, changes with the governments and so on. And the only solution I personally see is communication and agreement, and not only communication from top to down, but both ways. I'll stop by there.
Just I wish to add one element. When we address climate change or environmental issues, we have one catchphrase, which is think globally, act locally. So when we are talking about the climate change issues, at the global level, actually mitigation is one of the priority. At the initial stage of the climate change negotiation, the climate crisis is not so accelerating like today. But as the pace of the climate crisis accelerates, every country wish to attach great importance to the adapting to changing climate. That's why these days, each country wants to have tailor-made adaptation policy, in particular the enhancing the resilience, also the addressing their vulnerabilities. Thank you.
这样可以吗？好，不晓得哪位还有其他 question？ 要是没有，我想请问徐副署长。哦，来，
好，这边有一个问题，谢谢。
Okay, I have two questions. One is for Dr. Japola. Okay, one is you mentioned about as European, they are over 65%. Their lack of sufficient information to face the disaster or climate impact. So the EU have ways to improve their public awareness. That is related to you mentioned about the preparedness union policy. So that's question one. The other one is for Chairman Choi, you mentioned about, I totally agree that the measuring about the adaptation outcome is more complicated compared to the emissions. So do you have a solid solution to deal with such part of the questions?
Thank you for the question, a very good one. Indeed, the preparedness union strategy has a means to move forward to that, and I was saying that we are more impressed what is happening here. And it was in the central weather administration slide was all the SMS and so on, and I actually personally got one of those warnings when I was here, and I was my phone was vibrating on the bed, and I was, what is this? But it was for the heavy rains, yesterday or the day before. So they are very similar to what the Central Weather Administration mentioned, to improve those. But I have to say, it seems a lot more advanced over here. That you keep saying that you need more community-led building and so on, but I can honestly say that it is more advanced over here just by simple stuff like giving SMSs to even tourists. I mean, we have sometimes trouble to giving it to citizens and so on because we cannot necessarily agree on the same format in all the countries on the SMS, which goes back a little bit answering there. So yes, if you want to get deeper, you Google the preparedness union strategy, it will have different kind of, it's labeled population preparedness, but also increasing early warning translation for citizens. And I was partly shocked, partly surprised, partly like very intrigued by, I think again in the Central Weather Administration, it was that you even give the probabilities of the typhoon hitting. You would never give probabilities in Europe because nobody would understand what are these probabilities. And you have levels, from red to green and so on, because probability is too complex to understand for Europeans usually. So, I mean, working towards that direction. So.
Well, it's not easy, but I would like to say that there is no one-size-fits-all solutions. So that's why when we face some difficulties, in this case, I think what is most important is we should not fear to negotiate. But we should not negotiate because of the fear. So instead of fear, maybe we can put the word complexity. So that's why there is no the best solution, but I would like to say that there is no one-size-fits-all solution. So we need to take a practical approach. Thank you.
好，不晓得大家还有没有其他问题？征求最后一个问题。若没有，来，请。
那个有一个问题想要问那个吕署长，就是要
等一下，吕署长不在。
那
私底下再问，找时间再问吕署长啊。
哦，好啊，
因为
好。
他可能有要务先回去了。
好。
还有吗？不晓得大家还有没有其他 question？ 我可不可以耽误1分钟？我想请教那个徐副署长，不是最后一个徐副，那个我们很熟。我想要问国土署的徐副，在推动地方的国土计划碰到的困难是什么？我们在气候署的时候，我曾经跟徐副是同事，我们对推地方的调适计划碰到很大的阻力。他跟你说没钱又没人，那我不晓得国土署在这个经验上能不能分享？
好，其实因为有直播了，其实我们还有很多，应该讲我们也有很多的努力的空间。主要是地方如果谈国土计划，就谈那个土地国土的土地，地方是怎么想象土地。然后，因为我们是一个民主制度，然后再来我们这个民主制度，其实任何一个地方未来都会去做我们中央的长官，因为台湾的范围的事情嘛，所以地方社会怎么想事情，他就会怎么看我们给的政策，他要怎么反抗或因应或接受，所以这是很真实的事情。所以我觉得如果有更多的对话，然后有更多的社会我觉得我们台湾其实在地方社区的投资很多，这都是我们的可能性。这些人只要，我觉得先跟他们聊，再进行政策的指导跟指引，比较容易可以到地方去处理，这是第一块。那第二块其实是，在还没形成政策的时候，最理想状况，我以前在地方政府曾经尝试做地方的一些比较观念不一样的做法的时候，就诚如我刚才简报，你就是第一件事情要跟人民一起讨论出结果，那是人民要的。其实人民有时候的反对不是他不要，是他听不懂，或是他马上面临他马上碰到的问题。好，所以你要在前面处理。 第一个那是最理想，那就表示还没要实践的之前就应该做这件事情。这也就是我跟我们同事分享，我们要开始做这件事情。第二个事情是，其实当初在推国土计划的时候，法正在开始成立的时候，我那时候在地方政府，我就很特意跑到那个内政部，然后就秀了一张照片，想要给长官看，然后结果现在我坐在这里。奈及利亚，他在推国土计划，我先举这个例子，他就用一个小小的货柜车，把国土计划要做什么事情，在那个里面，当然过去还没有这么多数位那个工具，所以你也不容易读得懂。他就去每个国小，就停在国小操场，大家走一遍，再来谈，类似的事情。当然，气候变迁有更聪明的事情，我觉得这叫治理了，这叫 governance， 这要从他的灵魂上跟他沟通啦。这件事情如果做，一定更顺。当然，如果时间没有的话，另外一件事情，其实我觉得是可以去做相关的部分，其实就是设一些地方的办公室，同仁直接，当然很辛苦了，同仁直接下去跟他们一起创作，跟县市政府一起创作，这是如果要更快的方式，这或许是一种方式。那不然的话，你只要高高在上，大家都不会习惯。然后那个县市首长有他焦虑的地方了，除非他刚好焦虑这一个点，不过几率不大了，所以大概是我初步应该是不是我们的做法，而是我想要碰到我们的极限或我们做不好的状况之下，我觉得未来有机会这样子做的一个参考，提供大家。
好，非常谢谢。好，不晓得各位还有没有其他 question？ 如果没有，我们是不是热烈掌声？谢谢几位。
好，我们掌声谢谢台上与台人还有主持人精彩的分享。麻烦请台上贵宾移步到舞台中央来大合照。Now we invite the guests on the stage. Please move to the center for a group photo. You can remove your interpreting headset. Thank you very much. 好，我们请贵宾移步到舞台中央，我们一起来大合照。麻烦请往前一步 ，You can take a step further. 我们稍微往前一步，离相机近一点。好，来，我们请看向前方。Look at the photographer. Give us your big smile. 3, 2, 1. All right. 好，我们掌声谢谢台上的贵宾。Thank you once again. Please return to your seat. 再次感谢。好，各位贵宾，接下来我们是休息时间，在场外备有茶点，欢迎大家可以自行取用。另外也提醒大家，本会场禁止饮食，感谢各位的配合跟见谅。茶水间位于面对报道处的左侧，那外面也有循环杯提供给大家使用。那出入口在正后方，洗手间在出入口的左右两侧。那我们下一个场次3点40分准时回来。Ladies and gentlemen, now we're going to take a break. Please help yourselves to the refreshments outside. And no food and drinks are allowed in this room. You can feel free to go to the bathroom outside. And also, the next session will start at 3:40. Thank you very much. 好，我们大家休息一下，待会儿回来。 Come back。接下来我们将进入到第二场次，主题是资源循环。Now we would like to move on to Session 2, Resource Circulation。接下来让我们邀请日本国立环境研究所资源循环研究室 Hirofumi Sakanakura 室长。Please welcome Hirofumi Sakanakura, Section Head of NIES Japan. 他的讲题 He will talk about circular economy and environmental reliability in Japan's construction industry. 我们热烈掌声来欢迎讲者，有请。
Thank you very much for introduction. Nice to meet you, everyone. I'm Hirofumi Sakanakura from National Institute for Environmental Studies, Japan. And today I'd like to talk about the circular economy and environmental reliability in Japan's construction industry. Okay? So I'll try to use this. Okay. So the first slide is the planetary health. Planetary health means several aspects to keep the Earth's health. So resources, in terms of resources, the resources are limited and the extraction should be minimized. So therefore, it is necessary to realize the circular economy to achieve the carbon neutrality and reducing the environmental impact and control the environmental pollution. Okay. So this slide shows the much amount of waste are disposed of in 1970s in Japan. And this is Tokyo's landfill site photo. So this is a very usual scenery in Japan. And so actually we disposed of much amount of the waste at that time. So this is, yeah, this is the capacity of municipal waste landfills and now rest years. How many years are rest for the landfill site? This shows the rest years is only 8.5 years or something, around 1978 to 1995. And this side is the industrial waste landfill sites, and the capacity is very, very small. Just only 3 years was left for the disposal of the industrial waste landfill. This means just after 3 years, the capacity will be full. So Japanese government enhanced the reducing the disposal waste amounts. So this slide shows the amount of the disposal waste to the landfill was about 100 million tons per year around the 1990s. But in these days, the amount was extremely reduced to the 1,300 millions, 1,000 million tons and per year. Okay. So as a result, the capacity of the landfill increased around 2005 to 2022. The years is increased to the 23 years nowadays. And as for industrial waste, the capacity increased to nearly 20 years. So nowadays, Japan's situation is improved. But so this is a result of the material flow in Japan. So you will see the total amount of the materials is about 1.5 billion tons per year, and just the landfill is only 13 million tons per year. And the recycling amount is 235 million tons per year. Okay, so the landfill is just very, very few material flow. But the landfill itself, the technology has been advanced quite well. So this slide shows the view of the Japanese landfill sites. This one is Osaka coastal landfill site, offshore landfill site. this inside this island, the waste will be landfilled. And these photos are the general landfill site in the municipal waste landfills, like this. So the waste itself is isolated from the outside. And so we can dispose, for example, incinerated ash and bulky waste crushed materials in a safe manner. And this slide, this fourth one is this one. This one is a capped or roof type landfill site. The inside is very similar with the left side one, but the roof is covered, so we can prevent heavy rain introducing, and also we can control the leachate amount. So actually, Japanese landfill technology has been developed enoughly, but the construction of new landfill site is very, very difficult. So we need to keep reducing the amount of waste. So actually, the waste amount generated aspect of the generating waste is flat. Flat means, flat means from 1990s to 2020, the amount is very flat. It is 4,000, no, 4,500 ton. It's difficult to calculate the amount from, so 5 million, 4,500 man, 45 million tons. 45 million tons to 40 million tons or something. And the case of industrial waste, its amount is 4億トンだから、400 million tons, and the amount is flat. So what I want to say here is the final disposal amount has been decreased very, very much. But when we look at the generation amount of the waste, the amount is flat. So it means we need to keep reducing the amount of the waste at the disposal site. If not, we do not have the space for disposal of the waste. Okay. Actually, so how to keep our reducing the amount of the waste for at the disposal site? We need to recycle waste materials in the construction sector. For example, these materials are the examples of the byproducts and waste available in construction. The construction and demolition waste, such as soils and demolished asphalt concrete, demolished concrete and sludge, discarded plasterboards, etc. These quite huge amounts are generated annually. And the ferrous and the non-ferrous slag from industry sites, the blast furnace slag, both slag, EAF slag, copper slag, ferronickel slag or something, they produced every year such a quite huge amount. And also coal ash is also generated annually. And the municipal waste and the sewage sludge, such as incinerator, bottom ash, and vitrified slag, 5 million tons are generated. And the sewage sludge, treated residues, 4 million tons are generated. So in Japan, we have just only 12 million tons of the capacity of landfill. 12 means, for example, just 23 million tons. It's over the capacity of the annual landfill site amount. So we don't have space for landfill, but we need to recycle these construction materials. So the governments are promoting the recycling. The Act for promoting the effective use of the, difficult. Act for promoting the effective use of the resources enacted, And in these items, there is a specific byproducts, including coal ash and the soil, surplus soil, and concrete and woods. They should be recycled. They are assigned. And so the construction recycling law is also enacted. The specific construction materials such as cement concrete, wood, and asphalt concrete should be or must be recycled as possible in order to achieve the recycling society. So specific construction materials such as cement concrete, wood, asphalt concrete must be separated, disassembly and recycling, etc. The setting target of the recycling ratio is 95% by 2010, wood 95%, asphalt concrete 90%, 95% or something. So the industries have been trying to recycle this huge amount of the byproducts in construction sectors. Okay, this is the Japanese version. And actually, the coal ash recycling is like this. From 1995 and until 2022, the amount was about 5 million tons, from 5 million tons to the 12 million tons these days. And the generated amount is flat. And most of them are recycled as cement industries. And the rest are civil engineering and agriculture and something. And the others mean the land reclamation in the coastal side and like that, okay? And this is asphalt and concrete lumps recycling. Here we have 30 million tons of asphalt mixture, and also crushed concrete, also 30 million tons we have annually. And most of them go to the crushed concrete, and we use it as a road aggregate. So as a result, about 99% of the crushed asphalt mixture and the concrete mixtures can be recycled as a road aggregate and the asphalt mixtures as well. So we established the recycling society or circular economy in Japan already. But what I would like to emphasize today is the trace harmful or toxic metals are contained in such a recycling materials. So in terms of the construction and demolition waste, the crushed concrete contains chromium-6, hexavalent chromium. And the chromium might be leached out when they contact with rainwater or precipitation. And also ferrous and non-ferrous slugs, they have toxic metals or fluorine and arsenic and lead, etc. And coal ash, it has many kinds of the toxic substances such as arsenic, boron, fluorine, selenium, chromium-6. And also municipal waste, incineration bottom ash and slag, it contains a certain amount of lead. So we already established the recycling society in terms of the construction sector. But we need to treat these toxic substances safely. If not, we might not be able to keep or continue the recycling. Okay? It's a potential problem, I would say. So we need to make a reliability, keep reliability in recycling. So actually, in the past days, a history of illegal dumping and environmental pollution has been occurred, and deep-seated allergy to effective use has been the old person has such a suspicious eyes. So present and future, we need to prevent environmental pollution incidents. So never happen again. So it can be a barrier to the effective use of all materials, okay? So we need to continue to earn the trust. So quality standards and the quality control and the distribution of management systems, such items should be provided, okay? So actually, we should establish the environmental criteria for the construction materials, recycled construction materials. So we should check the environmental standard. What is the environmental standards? In case of Japan, I'd like to introduce. In Japan, we have environmental standards and regulatory standards for the several points, such as tap water quality standards, and public water, river and lake and sea water quality standards, and also groundwater standards, environmental standards, and the soil environmental standards. And the regulatory limit values for wastewater standards, and the waste landfill criteria, and the soil contamination countermeasure act criteria. But actually, what I want to know, I want to get now is the construction materials quality standards in terms of environmental safety, okay? So actually, these environmental standards, the targets or each of the environmental media, not construction materials. So the industrial sides discussed which one should be referred and how to measure or how to judge the environmental construction material is environmentally safe or not. So this is the environmental standards and the criteria of Soil Contamination Countermeasure Act. And here is a public water environmental standards, groundwater standards, and soil standards. So these are the same value, basically. And here is the Soil Contamination Counter Act, reaching criteria and the content criteria. So we have about 27 items in Japan we have. And soil, in terms of soil and Soil Contamination Countermeasure Act, we have a criteria for leaching. Leaching means the unit is similar with the water quality standard, even though the soil is solid. The unit is milligram per liter. Why? Why same unit is because the soil is evaluated in Japan by after leaching test, by contacting soil with water and separate water and soil, and then we get leachate or elution. So we measure the concentration in the radiate, and they are compared with the criteria of this table. So soil leaching standards are basically the same as the water quality standards and groundwater quality standards, and expressed as a concentration in water. The areas are presented by leaching test, okay? So this is a method of the leaching test of soil leaching test. So in case of soil, the particle size of for the leaching test is less than 2 millimeters dia. So the soil is sieved and take more than 50 grams, and the water is added. The ratio is, the liquid-solid ratio is 10. So 50 grams and 500 milliliter of the water is added, and the leaching test is conducted by 6 hours shaking horizontally. And after that, centrifugation conducted, and the filtration using membrane filter. Then we get leachate or aerate. But what we want to get is the evaluation method of the construction material. Construction materials is not less than 2 millimeter, basically. Part of the materials can be less than 2 millimeter, but such as a concrete block or pavement bricks and asphalt mixture, they don't have 2 millimeters fraction. So before we establish leaching test for construction materials. We crushed these products under 2 millimeters. So we have the questions. The soil leaching test uses on just 2 millimeter sieve size, less than 2 millimeters. So to apply the soil leaching test, it's excessive to crush everything. So at what stage, and the next problem is, at what stage should we evaluate the materials? It means just after generation of such as crushed concrete, or after sorting, should we evaluate? Or after mixing with other materials for the recycling, should we evaluate at that point? It's a problem. At the time of reuse or at the time of disposal, so which phase, which timing should we evaluate? It's the next problem. So industrial science discussed about this issue, and we established environmental safety quality in 2012. The Ministry of Economy and Trade and Industry established a study group with the aim of introducing the environmental safety quality standards to prevent the recyclable earth and stone resources such as slag and coal ash from having adverse effects on human health and the surrounding environment. Okay? So after discussion, we proposed basic approaches. One is focusing on the most dangerous exposure environments throughout the life cycle of the recycled materials, including their further reuse. It means first they are product shaped material, but after usage, for example, building might be crushed after 10 years or 12 years or 30 years or something. Then we should focusing on the most dangerous situation. It means after crushing, the toxic substances might be leached out from the materials. So recycling phase might be more dangerous than the first use. So we focusing on the most dangerous case. And the next point of this approach is two-stage inspection. A full item inspection called environmental safety form inspection, and a full lot inspection called environmental safety delivery inspection. So I will explain later. And this basic approach has been applied to the slag aggregate for concrete, such as JIS A5011 and JIS A5031. So environmental safety formal testing, samples are prepared assuming the reuse as roadbed materials, and JIS K0058 leaching tests are conducted in their original form. And the environmental safety delivery inspection is conducted leaching tests using slag only. So I'd like to explain some details. The focusing on the most dangerous situation throughout the materials life cycle means the construction materials can be the life cycle is the first, of course, construction. And the second is a use, and third is a demolition, and the fourth is a recycle. And during the construction, the materials, fine particles might be scattered in the around area. And the use phase, the scattering or abrasion or leaching might occur. And the demolition step, they are crushed and mixed with soil. Some part might be mixed with soil. And in the case of recycling, the surface exposure and the mixing with soil, in case of concrete, crushed concrete, they are recycled as a crushed roadbed aggregate. Okay, so which one is the most dangerous? We focus on it, and we evaluate such a phase, and apply leaching test. And two-step inspection method is a form inspection and delivery inspection. Form inspection is a check if the material or products meet the environmental safety quality criteria by simulating the actual specimen, or in some cases, specimen is crushed soon, in order to simulate the aggregate shape. So sample preparation and the method simulating the use condition. All items must be judged. All items mean that, so there are 27 items provided, so we might be required to check the 27 items. But we can reduce it reasonably if there's a reason. And the case of delivery inspection is a speedy assurance of the environmental safety quality on every material products on the same manufacturing condition, the use of the slag as it is, and for every shipping and material products. And the judging items can be reduced, such as only lead or only hexavalent chromium or something. So it's very, very easy compared to home inspection. So home inspection, we do just only once per year or once per 3 years or something. And delivery inspection, we apply this test every month or something. Okay, so we can reduce the effort to test the material. And this is the reaching test for products and granular materials. Sample this is like this photo. The specimen can be applied without crushing. Granular materials without size reduction. And asphalt concrete, cement concrete, such a specimen can be directly applied. And we need less than 5 kilograms of product as it is, and the liquid-solid ratio is 10, and the leachate is pure water, and the stirring is 200 times per minute and 6 hours. So in some cases, specimen is crushed before the test, assuming the recycling after first application. Okay? So it depends on the definition of sample preparation. And another one is acid extractable content test is regulated by Ministry of the Environment, notification by number 19 in 2003. The very, very fine particles might be into the mouth and ingested and digested in the stomach. So we simulate it. So less than 2 millimeters sample, 100 milliliter of 1 molar hydrochloric acid, and 2 hours shaking, simulating stomach, and filtration by 0.45 micrometer membrane filter. Okay. And this is the environmental safety criteria for materials, recycled materials. We set 2 types of the criteria. One is a general application, and the other one is a port applications. Port application is more loosened because the application is at the site of the sea side. So the values of the leaching criteria is 3 times higher in the case of port applications. Okay, and the content is content means acid extraction test result. And so acid extraction is how to say? It's a direct ingestion to the mouth. So if we use the materials in near the sea or port, the direct taking can be omitted. So we didn't provide the content criteria for port application. So we so you can estimate that we are trying to get some more reasonable criteria for the industrial side. So if we choose severe environmental standards, it might we can achieve very, very safe environment, but the industrial activity can be too much limited. So I think the balance is very, very important to control controlling the promote the industrial activity. Okay. So this is a categorization in setting the environmental safety quality. In case of the, for example, the case of E, building material, cost park, and building big lifting of the cost, it's very similar with the soil application. So they are called type E. It means similar with the soil environmental criteria, the same. But in case of the pier, river dike, road dike, railway dike, and tide breakwater and disaster prevention forest, they can be somewhat loosened criteria can be applied. So we classified such a, depending on the application, we change the criteria. Okay. So such an activity was, the peak was 2012, or around that time. After that, we established many types of the JIS standards or some technical manual or guideline or something for the general one or ferrous slag, non-ferrous slag, coal ash, gypsum, or disaster waste. So these are all including the environmental safety quality. And these days, actually, it passed about 10 or 15 years. So we started to review the efficiency of the this environmental safety evaluation methods, and we might revise some part of the guideline or the JIS standards in next 5 years or something. Okay. Okay, so that's all of my presentation. Thank you very much for your attention.
Thank you very much, Mr. Hirofumi Sakanakura, for your wonderful sharing. Please return to your seat. Thank you very much. 好，那提醒我们接下来的场次，由于时间比较有限，我们请各位贵宾记得将您的演讲限缩在20分钟的时间。时间到，我们的工作人员会举牌提醒。非常感谢各位讲者的配合。接下来我们邀请环境部资源循环署赖莹莹署长。Now we would like to invite Director General Ying Lai from the Resource Circulation Administration Ministry of Environment。署长他的讲题是 She is going to talk about circular economy in the face of climate change。各位贵宾，我们热烈掌声欢迎署长。
各位先生女士，大家午安哦。那我想，就接下来由我来跟各位报告，现在环境部那在资源循环的一个做法，好。好，那这张就是要告诉各位呢，我们现在正从我们的回收经济呢，要转型成循环经济，也就是我们过去是回收资源回收，迈向资源循环，那现在呢也即将要来这个逐步朝向循环经济的一个方向，好。那这张是告诉各位，这是国际上我们在推动循环经济呢，各国都有一些政策，还有一些做法哈。那其中也包括日本，在去年有发布的第5期的一个循环经济的国家计划。好，那在台湾呢，我们告诉各位，我们是要发展一个废弃物减少环境冲击的最小一个循环的一个商业模式哈。那这是一个我们是一个极具挑战性的工作，因为我们过去我们是用法规，那怎么样能够让我们的永续产业化，让我们的产业可以永续？好，这是一个用过去不同的思维或不同的方式哈来推动的哈。那这是我们台湾呢，回到台湾的我们面临的挑战哈。包括说刚刚跟各位报告的一个思维要转变，好，就是我们要从这个回收变成循环哈。那以及呢，我们现在我们要减碳呢，循环经济是一个非常重要的手段。好，那第3个是呢，台湾呢是很依赖我们进口的资源，好，所以提高韧性也是一个推动循环经济一个很重要的因素哈。那最后就是我们能够去有效的处理废弃物，好，因为台湾在这个掩埋的空间不够，以及呢我们的空间还有我们的人口密度很高，那这些邻避设施呢的设置呢都是非常困难的哈。 那为了能够推动这个工作哈，所以我们在行政院这边的12项关键战略里面，战略8已经提出了我们整体国家的一个循环经济的计划。那这是在计划里面呢，我们的10个关键项目以及指标，好，所以包括现在大家在全球关切的塑胶，以及生物质，还有我们的纺织品、电子电器，好，都是一个现在在台湾推动的一个重要工作，好。那在指标的部分呢，也从原来的妥善处理率、资源回收，那迈向了资源使用效率，以及我们的物质消费，人均物质的消费量，还有一个循环利用率，那这个部分有很多也是参考我们日本的一个指标。好，那接下来就跟各位来报告，那我们在台湾怎么来推动循环经济这个工作哈？我们定定的一个策略就是3个策略，包括从这个绿色设计，那废弃物减量，那还有我们要能够去资源回收跟能资源的利用，以及最后的妥善处理。但是要推动这些工作呢，需要有2大支柱，所以在一个技术创新还有制度法规，那另外一个第2个呢，就是我们要有很好的网络。才能够建立这个我们能够去让它循环不要断裂的一个系统。那以下呢我们就整个几个策略呢来跟各位报告。那后面呢会有一些实际的案例。那在这个绿色设计废弃物减量部分呢，现在的绿色设计我们会从几项我们包括电子电器或者是纺织品。好，还有我们的塑胶，来开始推动，好，那以及呢，现在呢，我们要能够延长使用寿命，好，所以会推动像修缮，还有服务，好，还有租赁的这些工作。好，那为了推动这个工作，目前已经把主要的政策呢，放到我们的资源循环推动法的修正草案里面。好，那这个法呢，现在打算呢送立法行政院来审查。好，那希望在今年的年底，在9月、10月呢，可以从立法院来去审查。那会包括把未来我们5年之后要推动一些策略，还有一个政策呢，都能够放在里面来订定。那作为一个引导我们循环经济的一个重要的法规跟一个方向。好，那首先呢，接下来就跟各位说明几项我们重要的几项的重点的一个推动的方向。那第一个面向是我们的生活面哈。那我想我们民众的生活怎么样从它的回收以及达到一个减量一个工作，好，这是第一部分要跟各位报告的。我们在过去呢在民国86年的时候开始就有个资源回收的4合1的计划。那这个计划呢是借由我们的回收基金大概有1年有100亿的一个经济诱因的补助，然后可以去带动我们的回收的企业呢可以来这个整个一个回收诱因跟不足的一个补贴的工作，还有加上我们的地方经济队。那第4项呢就是我们的社区的民众呢，他能够结合一个小的单位来做一个回收的推动工作。那我们怎么样从这个回收工作来迈向我们生活里面要来这个做的一些减量工作哈？那现在有推动了几项重要的策略，包括说我们现在要建立新的一个生活模式，还有消费的模式。那还有一项是很重要，就是我们的塑胶的减量，还有一个生产的一个减少哈。那我可以从我们这个最近几项重要工作来让各位了解哈。那像我们这一项就是零废弃社区，好，那这是一个从今年开始的案例，在台中的宫老坪，它可以结合这个除了回收工作，它可以结合一些我们手机的 APP， 好，让民众他回收呢有一些经济诱因可以马上回馈回去。好，那此外呢，它也可以在这个社区里面呢，去推动我们农业剩余物，能够去再制成一个产品的工作哈。好，那用这个社区，我们用这个社区为单位，那有引进我们的地方环保团体，还有我们相关的学校的老师， 还有我们的回收业者呢，一起共同来让这个社区的一个零废弃的工作呢能够去运转啊。那第二个呢，就是我们这个是建国花市哈。好，建国花市因为在塑胶袋在台湾是很多的，我们从建国花市呢把这个我们现在在菜市场里面不容易管制的一个塑料袋，我们希望说能够去带动民众呢，他愿意来，像你买花是很喜欢自然的，好，但是你可不可以用这一份心来改变你的习惯哈？所以我刚刚也就是一般来讲，我们在台湾的民众他都会很这个接受环保的概念哈。可是怎么样去改变这观念，可以身体力行哈？所以我们就打算用半年的时间，那在这边有设一个回收站，让大家可以来借用环保袋，以及使用这个二手袋的一个工作哈。那另外就是在生活面呢，有一些活动哈。那台湾人是很喜欢去看棒球的哈。那在棒球活动呢，我们去导入一个你要使用循环杯，你要回收还有这些球具球衣呢，可以来再利用再使用哈。好，还有这个就是我们要推动一个修缮的工作哈。这是在台北一马村。好，那目前在国际上有这个在社区有一些国际的咖啡馆维修站，那我们利用这些机制呢，把它整合起来，那也搭配在10月的第2周有个国际维修日，把我们台湾的这些维修的社团可以结合起来。那这都是利用社区呢，让民众呢，你要从一个线性经济，这个大量消费、大量使用的这个习惯下面呢，希望改变我们可以回到简朴，减少废弃物的一个生活习惯。那第2项工作呢是产品的策略。好，我们也从永续的产品来影响大家呢，这个我们的消费量，从一个产品的设计开始呢，就可以考虑到后端的回收跟修复使用，那以及呢后端可以去回收哈，还有我们能够去把这些循环产品呢进行一个循环采购。那这个架构呢已经放到我们资源循环的推动法里面哈，所以会包括像这个绿色设计有几个元素就是单一材料，还有易拆解那以及呢就是可以延长这个使用寿命跟容易修缮那第2项工作呢就是源头减量那还有我们的资讯揭露我们的产品的履历的建立让大家可以去追踪它后续的一个可回收性那现在是有产品数位护照来这个一起来做那第4项呢就是刚刚有提过的延长使用寿命，就能够用个租赁的方式还有修缮的方式来我们让我们的这个使用的产品的一个寿命呢能够延长那这些是项目之下的一个产品呢，我们把它叫做循环产品可是下面的一个采购是非常重要的那你生产的这些循环产品或这些循环服务要能够让民众可以消费到所以我们会有一个以后怎么样来鼓励的消费的方式，那也建立一些我们绿色设计的一些指标好，那在前面是策略，那为了推动这个工作呢，我们有在设计中心的一个设立，那这是希望呢能够当做个场域，把刚刚的循环产品的展示，以及我们对这些循环产业辅导，还有能够把我们的废弃物原来要废弃的这些东西能够去再制的再设计呢，在这个场域呢能够来实现那第2个呢，我们要对这些循环产品呢，台湾有很多的一个循环产品的一个品牌，我们要把它打造起来共同来行销，那变成我们绿色的品牌。那为了推动这个工作包括前面我们要能够去溯源，要能够标志还有这个鼓励跟这个行销都是未来要能够在一起推动的工作那第3大部分呢，是我们物料还有产业的循环那我们把这个物料呢依据国际上一般的一个分类原则就是有生物质，还有我们的无机物无机物就是刚刚我们日本的一个 环境研究所的博士，他有提到的一些我们无机物的一些运用，还有一个检测，像这些，那在台湾呢，都有来推动作为力量，那当然刚刚我们的讲者他也讲得很清楚，就是对于这些测试还有标准，那怎么样去影响环境？那这部分台湾呢也有来跟参考日本的做法，也有定出一些相关的标准跟做法。那唯有这样的一个好的处理程序，那通过了一个有一个好的一个管理标准，它才能够真正的作为这个力料的使用哈。那其他像我们的金属还有我们的生物质跟塑胶，也是用同样的道理再来推动。那为了推动这个工作呢，首先呢要能够去建立我们的这些物质譬如像无机物它的一个物质的来源，还有去处的一个资料库那把资料库建立之后呢，我们可以要进行分类，还有这个管理以及后续的一个推广的，还有监测的工作好，那在产业有这些循环能够去建立链接，可是最重要的是产业它能够去形成商业模式来运作所以环境部也跟我们的几个相关的产业，像刚刚的一个塑胶、纺织、电子电器，那成立8家人联盟，那藉由这个公司对话呢，才能够去了解我们在法规要怎么来订定领导它走向循环，以及企业呢它需要的一个辅导的工作好，那为了能够去推动一些设施，还有一个土地跟园区那我们也研拟了气候科技循环园区来作为未来设施推动一个必要的一个场地的运用。好，那关键战略物资呢，是一个我们在这个产业里面目前很重要的再也是因应说我们在产业韧性里面需要来做的那因为现在在有些金属可能在生产端会有一些限制，那台湾呢没有这些矿产的一个存在，可是我们是从城市采矿的方式来把我们这些关键物料可以把它找出来。好，那在企业我们在这个创新跟研究呢，也是需要来这个推动循环经济一个很重要的工作。那也建立了这些物质料的流向，还有这个它的不管是说原料废弃的进口跟出口的一个物质流向图那会根据刚刚讲的4大物料来建立那整个会统一在资源循环云的运作里面好，那未来也希望说，把我们台湾这些循环产业呢，能够去跟国际链接。那现在规划像大洋洲、东南亚，还有日本，都能够去进行合作。那今年呢，在10月20号跟23号呢，我们也要举办这个循环经济亚太2025的亚太经济的循环经济的论坛跟这个热点的活动那在这个3天的活动里面呢，会把产业在台湾循环产业的目前的表现那以及我们要提出现在我们未来的一个国家的循环经济的路径图接着第3天呢，是有我们在推动循环之外，那如果要迈向循环经济，包括在循环的采购、绿色的金融，还有国际贸易，那以及我们的一个教育，跟绿色设计等等这些未来需要推动的一些要素跟方向呢，在第3天呢来进行讨论。那也希望借由这次机会呢，能够在企业不管是说国内或国外的企业呢，我们也会有一个媒合的一个机会。好，那这个社会沟通也是很重要我们也在宗教的活动还有这个妈祖绕境这些，还有我们的教育呢都一起希望可以来从小或者是说不管的族群都能够带入我们循环经济的观念那后面是几个案例，那我想时间关系呢，我就先讲这个咖啡渣的案例好，那这个是生物质那各位知道说原来在生物质呢， 我们会有农业单位来管理哈，但是它形成一个它被制造变成一个食品之后呢，就会变成工业单位，或者是说我们消费者这样的管理。那因为它要跨到不同的一个产业别跟管理的模式哈，所以我们就能够去利用刚刚讲的8加 N 把这些在农业、商业跟民众以及后端的一个循环利用呢，能够去串联起来哈。那这个案例是我们在全家饭店，我们有很多的一个咖啡的这个喝咖啡，那它的渣呢，如果是说很快可以收集到干净的，而且很快可以运用到这个使用端的话呢，就可以做成高质的产品哈，譬如说，像现在有衣服的机能衣呢，它会有再生料之外，那添加这个咖啡渣。那全家饭店呢，全家的便利商店，因为它有全省有各地的一个商店，那如何把这些集合起来？可是呢，它可能会面对不同地方环保局的一个管理，所以由它来提出一个整体，就是全国各分店的一个计划。那由环境事务这边呢，找了各环保局一起整合，好，让它变成一个运送跟集中的比较有效率的管理方式，那不用一一的去跟每个环保局来这个做一个申请，还有这个追踪哈。那由环境部这边有一个全国的一个它的一个咖啡渣的回收计划来做。那咖啡渣因为它要做个收集，那还有这个脱水之后呢，那之后就可以做成像衣服哈，或者是我们的一个这个吸碳，或者是最后呢像这个我们的这个木炭的这些就是不同价值的一个产品哈。然后想这些案例呢循环产品包括说你从这个废弃端的回收到后面这个产品这个链接呢，我们会一一的来按照我们每个产品的一个特性来做哈。那以上就是我的报告呢，敬请各位指教，谢谢。
好，我们掌声谢谢署长带来精彩的分享，我们有请署长回座，非常感谢。好，谢谢，有请我们请署长先行回座。接下来呢，让我们邀请中原大学王雅芬教授。王教授目前也是台湾资源循环产业推动协会的秘书长。Now we invite Professor Yafen Wang, 中原 Christian University. 他要分享的主题 She will talk about from waste to recycled resources, key technologies and innovative applications in Taiwan's circular economy. 掌声欢迎。
Okay, good afternoon, ladies and gentlemen. It's my honor to be here to share the technology and innovative application in Taiwan. So I'm Yafen Wang from Zhongyuan Christian University. So in the beginning, I would like to discuss about how resource recycling and circular economy drive the sustainability. Today we redefine the West. You understand the West is no longer the West. It's a misplaced resource. So as the Director General Light reminded us, the future lies in maximizing the resource and minimizing the waste. So the resource circulation and the circular economy are not only concepts, it's the pillars of the sustainability. So for instance, recover the aluminum can save up to 95% energy compared to using the virgin material, and it also reduces the carbon emissions. So when we reuse the material, we also preserve the nature for future generation. And around the world, there are some powerful examples. Japan achieved more than 95% recovery of the e-waste material. And the Netherlands mandated the circular material in public building. And the Taiwan showcases the innovation through the Thai sugar circular village, turning the idea into impact. So the resources recycling and the circular economy are not only environmentally necessary, it's also economically smart because compared to landfill, it creates 10 times more jobs per ton of the material processed. So it fuels the innovative business model, such as the product as a service and the creative upcycling. So I think it's more than a win-win policy, because every step, we are not only growing our economy, we are healing the planet. The target is we build a world where nothing is wasted and everything has the purpose. But the very important basic is the technology. So let's go into the technological pathway for the resource circulation. This is the project executed by the team at Zhongyuan Christian University and ITRI. In the work, we develop a comprehensive roadmap for the resource circulation. And the roadmap is organized into 4 levels. Level 1 is the fundamental material resource. Based on the RECA policy, it's the biomass, organic, chemical, metal, and chemical, and inorganic sources. And level 2 further classifies these materials into the relevant product type. In total of 20 key product types mapped to the global priorities, referencing the EU Green Deal and the Japan Strategical Initiative and the Taiwan Net Zero actions. And here are examples. Level 3 is the circular items within each product type. And we summarize 66 specific material items with high circularity value and identified under each product type. And level 4 maps the enabling technology. And this technology draws from both domestic innovation and international best practice. So these include the green design, recovery, recycling, carbon reduction, value up, and verification and tracing. So based on the roadmap, we develop an expert evaluation framework. And in these 66 circular items in level 3, the experts score them based on the 6 key indicators, include the policy relevance, value waste, generation scale, and value addition potential, etc. And based on this, they can provide us to identify the technology which should be prioritized for development. So this is the complete and the final roadmap for the resource circulation. And let me take the inorganic resource as the example. This is the level 1. This is the level 1. And the blue one is, sorry. The blue one is the level 2, is the product type, and here is the circular items. And the red color indicates the top-ranked material that should have a priority technology. And we also concurrently collecting the existing and commercial technologies for circular technology. So this is the level 4. This is the example for the metal containing electrical and electronic material. This is the relevant circular technology and the introduction for your reference. And following, I will show you some commercial technological examples. And the first one is the plastic. In Taiwan, we turn the plastic into opportunity. On the left, you will tell we use the intelligent sorting to identify the plastic by color, by mass, by additives, and using the machine learning and near-infrared sensor. And meanwhile, The smarter recycling machines are installed in schools and malls to improve recycling efficiency and engage the participation. Although the marine debris is only 7% recyclable, however, in Taiwan, we use the physical and non-physical recycling technology to transfer these marine debris into the new products. And the second example is the aluminum plastic multi-layer packaging. We understand that it's a rising challenge in waste management because in UK, about 41,000 tons of the laminated packaging enter the waste stream every year. And in Austria, only 39% of aluminum packaging was recycled, and the recycling rate is not high. And the traditional treatment methods include the landfill and incinerator. However, both of them both of them are not only recover the valuable resources, but however, they will damage the incinerators because the molten alumina class the furnaces. So the Jie'an make a major leap in its first alumina plastic waste separation system. Start from the crushing the waste into the specific particle size, and by the uniform heating and via the precise screw control, we can separate the different melting point of plastic and aluminum. And plastic will melt and aluminum further remains solid. And we use the centrifugal and mesh to separate these two resources. And the molten plastic will be refined into pellets. And aluminum foil is compressed. And both of them can be remanufactured into new products. So the system does not only reduce the carbon reduction, they also transfer the waste into valuable resources. And it's also powered by the collaboration with the Taiwan semiconductor industry to collect and process the aluminum plastic wafer bags. These bags are considered cannot be recyclable before. And next, I would like to discuss about the e-waste generation. Over the past 12 years, the global e-waste generation are almost doubled, reached to 62 billion kilograms in 2022. And around 22.3 of this e-waste was formally collected and recycled. However, as you see, Asia is the major producer, but our recycling rate is only at 11.8%. This highlights the recycling gap and the rising amount of the e-waste is outpacing our recycling capacity. So these charts highlight the e-waste gap around the world. For most of the EU countries, their recycling e-waste rate is higher than the landfill e-waste. But in Asia, we see Japan and Taiwan, the effective policy and the proper regulation and enforcement can make a difference. And Taiwan and Japan, our e-waste recycling rate is over 50%. However, some other countries still landfill the e-waste and more than 75%. And we understand the problem and the challenge of the e-waste. And the e-waste also contains up to 60 different types of metals. The recycling cost of metal from the e-waste is far below the mining of crude oil. It's 13 times. Traditional e-waste technology included the smelting and the incineration, and they will produce the high carbon emission and the corrosive and the toxic substances. So we need a low carbon emission, safe and environmentally friendly technology. U-Win Green Innovation is one of the choices. So let me take the Apple product as an example. Apple is setting a bold target for their sustainable electronics. By 2025, all Apple-designed batteries should use 100% recycled cobalt. By 2030, the company committed every product will be carbon neutral, but how it works? So no matter it's the old iPhone or old MacBook, the e-waste that go into the Apple recycling system, and the e-waste, the devices will be dismantled, and the PCB board are isolated and go through the innovative stripping system, and by the intelligent sorting system, we can separate into different components like the board, capacitor, connector, IC, MLCC. And by the green stripper system, we can recover the precious critical metals. And this is the result. The tin stripping system, it's a low cost, and the recycling rate is over 95% in only 30 to 45 minutes. It significantly reduces the environmental impact. And next example, I would like to discuss about the construction work. And in the past, we understand the building demolition will generate lots of waste. However, based on the smart material flow plan, even a 16,000 square meter CDC's demolition construction can turn into a circular economy success. With the more than 31,000 tons of material were managed, it produced the impressive 99% of a recycled rate. And this is not only the waste removal, I think it's the value creation. So we see the construction site is very clean, well organized. It's preceding demolition, inside, out, top down, and that everything in order. And this is the example of the construction work. And the following, I would like to introduce two green design examples. I knew this is, I think this is a very cool example for a green design. I knew the brand Hi-Ban last month on an environmental education workshop. Each of the gas is made from the waste fishing net with no disposable packaging. So every part supports sustainability from the source. And the glass is not only lightweight, only half the weight of the regular eyewear, but also strong enough to withstand 45 of the pressure without the deformation. And the coolest is it's screw-free, no screw. Every part is detachable and by design. So it's a very cool example for green design. And the Spring Pro glass is another beautiful and powerful example for green design. From the beginning, the waste glass bottle, the company collect, sort, and clean the glass and give this recycled glass a new circular journey. They don't stop only at recycling. They go further. So, based on the green design, they create the cultural and the commercial products. So they produce this beautiful glass well, and their initiative like the pool and the W pool not only produce this glass well, they also put the culture in the recycling. And finally, I would like to introduce the Resource Circulation Industry Booster Association, abbreviated as RCBA. RCBA is a practical platform for industry, government, and academy. And we encourage integration and collaboration. We want to empower the resource circulation industry. We also want to value up the resource circulation industry. And here is the website for your reference. And I want to end up with the point. We should provide a value-up solution for the resource circulation. And here are the elements. There are many things that we can do. And based on because previously we said we redefine the West, that if you choose to see West as a beginning, not a West, and you will create a bright future for the next generation. So that's a value up for boost the resources circulation together. This is my presentation. Thank you very much.
Thank you very much, Professor Wang, for your wonderful sharing. Thank you for sharing with us all these wonderful cases from Taiwan. Thank you very much. 我们谢谢王教授带来精彩的分享。接下来，让我们邀请中央大学江康裕特聘教授。Now let's welcome distinguished Professor Kang Yu Chang from National Central University. 他的讲题 he will talk about development and rethinking of waste to energy technologies. 我们掌声欢迎。
Yeah, good afternoon, ladies and gentlemen. It's my honor to be here and to share my idea. I think you will ask me why did I select this topic for sharing my idea. As we know, around the world we face a lot of challenges, such as the waste generation amount increasing, and energy demand is rising, right? So I think this challenge will remind us waste to energy is very important part toward sustainability. Why did I say this? When I think about the net zero emissions, I think the energy, how to make sure the energy is high efficiency and the air pollution emissions can be reduced, and how can we use the high energies to provide our society. So I select this the topic to share my ideas how to rethink the good waste to energy technology. The first slide, I would like to show the evolutions of waste management in Taiwan. In this slide, I think everyone knows in past 5 and 6 decades, the first technology could be end-of-pipe technology, such as composting, incineration, and so on. However, 30 years ago, we focused on the waste reduction, recycling, and the recovery, like as 3R. And then we moved to the circular economy. I think it's a new trend for Taiwan and all over the world. And the next, the questions I will ask you, what's the relationship between the waste-to-energy technology and the circular economy? I think it's a big question, right? However, I think, as you know, the advanced waste-to-energy technologies converts the various type of the waste into the heat, electricity, and any type of the fuel, thereby providing a very important pathway towards a sustainable energy recovery. The second point is by transforming the waste to the different type of energies, and we can reduce the greenhouse gaseous emission, and we also can help to close the loop of material cycle in the circular economy. So we can conclude that waste-to-energy technology is a very important component in a circular economy. The second, the questions I will ask you all, what's the waste-to-energy in a circular economy role? I think everyone can consider this the answers. I think it's very important to remember that if we want to forward toward the circular economy, the goal always is to keep material in use as long as possible. However, what's the waste-to-energy technology's role? I think we can see the statements. Waste-to-energy should be seen as a last resort for treating the waste after reduction, recycling, and reuse, or any options. So we can say that waste-to-energy technology play a very important role, especially in a circular economy. The third questions I also need to ask you all, what's the drawback of waste-to-energies? I think everyone knows the drawback could be the waste-to-energy technology can produce greenhouse gaseous emission and any type of air pollutants such as dioxin and metal emissions. The second point could be the waste-to-energy often require a steady stream of waste for operations, for maintenance. So that is waste-to-energy always criticized some point because waste-to-energy technology can discourage waste reductions effort. So we can conclude that waste-to-energy technology should not replace efforts to prevent waste and keep the materials in circulation. So what's the conclusions? The waste-to-energy technologies, what's the important role? So I think I would like to introduce some overview of waste-to-energy technologies. I think we just very simplifies to divide the waste-to-energy technologies only into the four parts. The first is direct combustion. The second is physical transformation. The third is the thermal transformation and the chemical and the biological transformation. Why I use the transformation this term? So I think we also can use these tables, this figure to show you if we divide the waste-to-energy technologies into the two parts. One is the traditional waste-to-energy. As you know, the incineration, combustion, or anaerobic digestion, and so on. Another part is on your left side, advanced waste-to-energy. At this time, we have three parts. One is advanced thermal technology, such as gasification, pyrolysis, and plasma arc, and so on. Another is biological technology, advanced and aerobic digestion. And the final advanced chemical technologies like the hydrothermal. So based on this overview, so I need to ask you all, the physical transformations is possible to convert waste to energy? This is the new from Taiwan. I think in Europe have some the physical transformation. As you know, the SRF, like the solid recovered fuel. In Europe, can success. In Taiwan, how about in Taiwan? I think that you have some different ideas about this. I think that I want to show you this slide from the textbook. I think it's a very simple process. The physical transformations process just use straightening, separation, and some air gasifications. That's all. We can convert the heterogeneous waste into homogeneous waste, and we can call as solid recovered fuel, SRF. So it's a very simple process. And another process also from another textbook. So you can understand the physical transformation is not the new technologies. It's a common use. So I need to ask you all or rethink something. I just mentioned my ideas. If we want to use the physical transformation to convert waste to fuel, we need to consider some points. One is the waste property, the waste nature is suitable for converting waste to energy. I think maybe yes, maybe not, right? I think everyone, the answer could be different. The second point is the mechanical biological treatment technology is usable or not in Taiwan. I think in Europe maybe success. However, in Taiwan, how about in Taiwan? What's the problem? If we can find out the problem, maybe we can find out some solutions, right? The third point is the SRF, the quality is good or not. And following point could be what's the channel, especially for utilization or disposal channel, is open or not. Another is SRF is really can replace the coal or other fuel. It's really can replacement. I think the answer yes or not, right? So please consider this. So I just summarize my ideas, rethink this few points. Maybe we can find out some solution, and we can let SRF technologies the promotion in the future, okay? So the next slide, I would like to show you what's the advanced waste to energy technologies. I just mentioned some slides from textbook. As you know, the textbook just show us waste to energies can can classify as the 7 type, from RDF1 to RDF7. Even though at this time we didn't say the fuel as RDF, refuse derived fuel, we always want to say solid recovered fuel. Never mind, it's the same thing. So what's the RDF? Based on the ASTM from the textbook, RDF1, such like the refuse combustions. The RDF2, such as just a very simple separate. some inorganic fractions from the West, like the West homogeneous. RDF3 maybe use some strata, like the West into the small particle size. RDF5, 4 and 5, I think is common use in Japan, maybe RDF5, like pellet, like the stray and separate. After the shredding and separate, like the organic fractions more and densified into the pellet, we call as RDF5. RDF6 convert the waste into the liquid fuel. RDF7, as you know, maybe we can call as gasification. Just use the waste convert into the gaseous fuel, such like the hydrogen or syngas, such like this. So we can see these figures. Y-axis just the fuel level. X-axis like the energy efficiency. We can see this figure from RDF1 increase the energy efficiency to RDF7. So what's the next? Maybe we can have a different idea. Maybe not the SRF, RDF5, maybe we can enhance the fuel quality, energy efficiency to high. Maybe RDF6 or RDF7, maybe. So I think I would like to summarize some criteria for evaluate some efficiencies of advanced RDF, not RDF, advanced waste-to-energy technologies. I just mentioned some criteria for you. The first is maybe we can evaluate or consider energy efficiency. Like the efficiency, we need to consider energy input and energy output produced. If can recover more energy into the process, maybe the technology is better. So just consider energy input and energy output. Less energy input, more energy output. I think the waste-to-energy technology is better. The second criteria is waste reduction. Of course, we need to use waste-to-energy technology to reduce the waste amount. I think that just consider 1 point. Less residue is better. That means higher reduction rate is better. Less residue, because residue such like the fly ash and butter ash is more. We also need to consider what's the disposal method. The third point is we need to consider the environmental impact. I think everyone understands the waste-to-energy, the problem always criticize air pollution emission. So how can we evaluate just from the end, all lifetime? That means we can use a life cycle assessment to evaluate from collection and the preparations of the waste to the end use of the energy produced. And we also consider the emissions produced during operation and the environmental impact. It's a very important thing. The fourth point, we also need to consider the economic the feasibility, capital cost, operations cost, and so on. And finally, we also need to consider waste-to-energy always criticized by community, by people. So we also need to consider social impact. We need to face the people to communicate the waste-to-energy technology is very, very important. And it's also need to integrate to the circular economy. It's a very important part. And the potential health impact from emission, we also need to say something to community, to the people. I think this slide just for your references. It's a another important thing. We use the cost benefits analysis to evaluate the waste to energy technology, which is the better one. I think that finally, I also need to ask you all, what's the next? If we select the waste to energy technology, what's the next? I think I just show you my ideas. Maybe it's a key issue for hydrogen energy. The second point is we also need to consider the key issue for carbon dioxide capture. Maybe it's only my few points for your the references. So I think this is a slide everyone can understand. If we use our governments provide the 12 key strategy for net zero emissions, we can find out the energy issue. Another is the resources recycling issue. If we combine together, I think maybe we can create the new future. I think we need to consider that. I can consider that, okay? So this slide just mentioned the hydrogen production method, maybe gasification, like the RDF7 technology is a very good solution. The next slide just overview the CO2 utilization measure. Maybe we can combine together. So I just remaining 2 slides to show you all. Future of waste to energy, I think that we need to consider some innovations of technologies. The first is maybe we can find out some new advanced gasifications with the tar quaking catalyst. Maybe we can integrations of pyrolysis with chemicals recycling. Also, we can combine the carbon captures and the storage integration with waste to energy plant. I think we also can combine the AI or AIoT for optimize the plant, the process. Maybe we can consider that. Finally, I think the summary and the outlook. I just show you my idea is if we use the waste to energy technologies in the future, I think we need to balance some approach between the recycling, reduction, and the waste to energy technology. Maybe we can find out some total solutions. I think this is my presentation. Thank you for your attention. Thank you very much.
Thank you very much, Professor Zhang, for your wonderful sharing. Please return to your seat. 我们谢谢江教授带来精彩的分享。接下来呢，让我们邀请环境部国家环境研究院毛许毅副研究员。Now let's invite Dr. Shi Yimao, Associate Research Fellow of NERA. 他要讲的主题 He will talk about a practical approach to upcycling technology for waste polyester recycling. 掌声欢迎。
各位贵宾、长官以及与会的先进同仁们，大家好！今天很荣幸能在这里分享这个主题——聚酯塑胶的升级回收。我们都知道，聚酯塑胶是民生用塑胶里面占比很大的一类，而与之相应的，它的回收体系其实也已经相当的完整。但是，随着现在全球化的永续发展以及近零碳排的议题，要如何让回收不仅仅只是回收？而是能透过回收让它升级，而用在更好的地方，这已经成为了全世界共同关注的一个议题。接下来的分享呢，我希望能和大家一起来看看，到底什么叫做升级回收，以及如何透过这样的技术路径，去真的把材料透过回收而让它变得更好。好，我们先从一个大家都比较熟悉的话题开始说起，就是全球塑胶污染的挑战。根据统计呢，全球1年会产生好几亿吨的塑胶产品，而其中有超过一半会在短期使用之后就被丢弃。而在这背后，除了说废弃物量居高不下的问题之外，其实背后又隐藏了另外一个问题，那就是现有的已经成熟的塑胶回收体系，大多是属于降阶回收。也就是说，它在回收的过程当中，材料的性能以及品质，它是不断的在往下降，以至于这个材料在再生之后，它只能被用在一些比较低阶的应用领域。 而升级回收正是为了跳脱这个概念。它在使用回收的过程当中呢，它使用技术以及设计，透过这个流程，它使得材料不但能拥有更好的性质以及品质之外呢，同时它要赋予了特殊的功能性，以至于它能应用在各种高阶的应用领域。这就是升级回收的核心思维。好，我们刚才有提到了说，现有的回收方式，或我们说机械回收法，它大多属于降阶回收，也就是材料的品质会不断的往下降。而升级回收呢，它是怎么样让它可以去升级的呢？它其实回收的方式是因为它一开始就先设定好它的路径。方法是这样的，它先设定好这个材料在回收以及再利用的时候，它运用在哪一个领域。而那个领域所需要的需求的一些特性，它在回收的时候呢，它用技术去把它设计成那个样子，也就是它中间过程当中不但是回收，而且它是改造了这个材料，以至于回收出来再生的材料，它就是能够适用于我们希望应用的这个领域的属性。那举例来说呢，其实如果我们希望这个回收聚酯在回收之后，它能够运用在运动的产业，例如说运动的机能衣，那我们可能就会希望这个材料它本身具有吸湿排汗，它具有抗菌以及抗紫外线的效果。而这样，如果以这样的心情做出来的机能衣，它就能够不但在人穿在身上的时候会享受到它的机能性以及便利性，更重要的是这个产品本身的环保价值也大幅度的提升。那如果是用在交通运输的领域，例如说我们是用在汽车的内装 ，OK， 那我们当然会希望说这个汽车内装它本身能够足够的坚固，而且最好它能够轻量化。如果是这个情境之下，我们用在汽车上面会发生什么事呢？就汽车本身它可以变得更坚固耐用之外，它变得比较轻，也就是它在行驶时它的燃油效率可以提高，而这也就导致它在行驶的过程当中它的碳排放量就降低了。那如果我们把它用在建筑领域，例如说我们建筑装修用的板材，而这个板材我们当然会希望说建筑要用的，我们当然希望它坚固耐用，而且具有安全性。同时，我们最好能希望它有功能性，例如说防水、防潮、防火阻燃的特殊效果。这样我们在住在这个建筑里面的时候呢，它不但能够更安全，而重点是它在这样的过程当中，它可以减少很多一次性材料的浪费。那实际上呢，可以看到这些技术本身都非常有价值，但是到底实际上要怎么做到这件事情呢？我们就要先从升级回收的基础，也就是化学回收法开始说起。好，我们先从塑胶材料，也就是高分子材料内部结构开始来看哦。其实，在这样的结构之下呢，其实这个是一个塑胶材料，或我们说肉眼看到的塑胶粒里面，其实它不单单仅仅是这个塑胶的这个颗粒的本身，它其实内部是由无数的高分子的分子链去堆积而成。而一个良好的完整的高分子分子链的堆叠方应该是像这个样子，它里头的分子链都有足够的长度，而且它的分布以及均匀性最好是要很好。那这个分子链又是怎么来的呢？它是有塑胶的原料，也就是小分子，借由聚合反应，它一个一个的连接上去的。那我们说，在一般的回收或传统回收里面，它会发生什么样的事情？在机械回收的流程当中呢，因为它的环境因素所影响，它里面会有高温、有水、有空气的存在，所以它在回收的流程当中，它材料的品质会不断的劣化。这个劣化就像这边图上所看到的，原本完整的分子链，它在经过这样的过程当中，它会不断的产生链的断裂，而这样链的断裂，其实最终就会导致材料品质的下降。而重点也不只是材料品质下降而已，它会导致另外一个问题，就是说它在某些特定的制程以及产品上，它产生致命的缺陷。举例来说，像人造纤维的制程，不晓得大家有没有看过？它是由喷丝头很快速的喷出丝来，另外一端是很快速的卷取机把它卷取成线轴，而大家可以想象，在这样连续性而且非常高压的制程之下，一旦这个材料产生了缺陷，它会发生什么事情？它就是这个材料会中间产生断裂，而这个制程就整个停摆。那这是它为什么人家会说，其实有些材料不适合这样在回收之后再去用在这些所谓的特殊的领域存在，就是因为它真的是没有办法被这样被运用。而化学回收法，它走的完全是另外一个路径，就是它一开始就是利用化学反应，先把这完整的分子链直接把它回收到，把它分解到最小单元，然后再借由聚合反应去把它聚合回去。大家其实可以看到，这样的过程当中呢，其实它跟直接拿新材料去合成的道理是一样的，也就是说，这个结果是可控的。 那这样的会导致什么样的结果呢？就是实际上以化学回收法制成去回收出来的材料，它就是能被用在原本它可以被用在的地方。所以化学回收我们通常要称为平阶的回收。那我们刚才提到的升级回收又是怎么回事呢？其实升级回收就是基于化学回收，我们同样的在第一步一样把这个材料先用化学方法把它分解成最小单元，但是我们在聚合回去之前，我们又额外加了一个步骤，就是我们要在这个时候希望运用的领域，我们先锁定好，然后再赋予它功能性。例如说，我希望这个材料最终它具有足够的吸水性，那我们在中间就加入亲水性的结构。如果希望这个材料最终它是具有比较柔软的性质，那中间我们就加入柔韧性的结构。那我们把它以这个方式去聚合起来，那当然，因为它本身就是一个结合了所谓的化学回收的方式，然后再导入了所谓的材料设计的概念，自然以这个方式所生产出来的再生产品，它性质就能够千变万化，然后去符合我们最终的用途。而这样又会带来什么样的好处呢？当然，其实我们原本它会被走一般的回收方式，它可能材料性质会不断的下降。那我们这是使用了另外一条路径，让它可以用在更高价值的地方，而且它的性质可以让它用得更久。所以第一个，我们当然首先可以延长这个材料的生命周期。再来，当然第二个也是最重要的，就是这个材料本身它的性质的品质会提到大幅度的提升。而再来，因为我们生产出来这样1公斤很好的材料，那我们实际上就是可以减少另外那边1公斤需要新生原料去制造，所以它其实在整体碳排方面也是非常有价值存在。那又介于这些所谓的好处呢，它又稳稳的可以扣合到现在的国际趋势以及政策，就是循环经济的推动方案、CBAM 碳边境调整机制以及再生材料的再利用指引。这也是为什么现在很多的回收研究，它其实都开始朝向这个方向，就是因为它本身升级回收的本身呢，它当然是一个技术的升级，但它技术的升级的同时呢，它带来是材料性质的升级，而这个材料性质的升级，最终导向的就是这个材料能应用领域的升级，而这个应用领域的升级，最后也会带来一连串的对于环境保护的好处。所以可以看到这件事情本身就是升级回收它本身最大的意义以及它的核心价值。那接下来呢，我们再看一下国内外实际的一些企业的案例。那这边我们都使用代号去在称呼它啦。第一个 A 公司呢，它本身是一个户外服饰的品牌，它本身公司的理念呢，就是导向所谓的环境保护，所以他们其实一直以来都是使用回收的聚酯材料大量使用，然后去制成他们的户外服饰的衣物。但是他们最重要的是呢，最近他们又开始走向了一个叫纺织品到纺织品的回收策略，也就是说，它使用了旧的纺织品把它回收回来，然后再把它借由它的升级回收技术，成功的把它做成新的户外服饰衣物。大家看到，其实这件事情本身并不简单，而他竟然敢宣告而且执行这个策略，就代表他掌握了这个技术，其实真的可以去把这些所谓一开始不好回收的东西，成功把它变成一个可以被回收的这个圈里面。这代表整个循环经济的链就被它给扩大了，这是它这边提供了非常大的一个价值。而 B 公司呢，本身是一个运动服饰的品牌，它其实是这样的，它和海洋保护组织去合作。他们大量收集了海洋里面的废弃物，例如说废弃的渔网以及废弃的保特瓶，他把它是由升级回收的方式，成功把它做成一双一双的运动鞋。而这些运动鞋已经不再只是说大家想象中的环保概念产品，而是实际上已经卖出了超过1000万双的潮流单品。在这边可以看到，它其实所谓升级回收，在这边并不只是一个技术，或者说它一个产品的诞生，而是说它把这个升级技术所导向的所谓的环保的最后的结果，它把这个意向把它升华到他们公司里面的公司形象以及行销上的亮点。那再来是 C 公司，它其实是一间时尚的品牌，它本身大量使用回收的聚酯，结合了生物质材料去做成他们的产品。其实我们从这个例子里面可以看到，升级回收的另外一个面向，就是实际上在这个例子里面，所谓的被回收的聚酯，已经不再只是所谓的低价的替代品，或是比较环保的替代品，它其实真的能够成功的利用这些技术，去让它打进了所谓的高阶的时尚的市场。 那在第一公司跟一公司呢，这两间公司是我们台湾的公司。那第一公司呢，它其实是一个，我觉得是以研究者的角度来讲，它是最典型的一个升级回收的一个结果，就是它本身是在产线里面利用它的技术去开发、去升级回收，然后成功的把这些废弃的聚酯转化为高强度的工业丝线、鞋材，以及运动性的机能性布料。然后呢，它其实带来的结果是，其实这些材料以及产品，为什么我说它最典型？是因为它所有的升级都是可以量化的，而且很直观的，可以转化成我们目标的一个所需要的功能。再来，一公司呢，它其实是我们台湾的品牌，它其实它走的跟 D 公司的方式有点像，但是它用的方式是，它把它的功能化变得更明显。它把它转化的目的是把它运用为医疗用的产业的机能布料，以及它高性能的一些机能性的织物。那从以上的这些例子可以看到，他们其实所有的公司，他们的核心思想都是所谓的升级回收，但是他们各个都是用不同的角度去切入这个地方。所以我们可以看到，所谓的升级回收在这边，它不仅仅只是一个回收技术，或者说把回收品变成一个有用的产品，而事实上是因为升级回收这个概念机制以及技术的成熟，使得他们可以把这些技术以及设计去让这些所谓的被回收品创造出新的价值、新的功能，甚至新的市场定位。我想这就是升级回收它最大的一个价值所在。在这边呢，我想再花一点时间去介绍一下我们国环院现在正在进行的高质化回收技术。这边的话呢，就是所谓的高质化或者说升级回收流程。大家可以从前面的例子可以听到，最重要的当然是中间这一步，就是我们要如何去改造这个材料，而且我们要用在哪个方向。那其实，在思考这个问题的同时，其实我们发现到一个点，就是如果我们希望最终生产出来的材料，它是能够有足够良好而且足够明显的功能性，那我们就可能在中间需要改造的幅度就越大。而当幅度越大，或者说改值程度高到某一个程度的时候，它会产生另外一个问题，就是这个材料它没有办法跟原来的材料一起被回收。大家可以想象像我们最常接触到的聚酯用产品就是 PET。PET 本身就是因为它有足够的生产量能，然后它就会有相应的背后的可以被回收的所谓的回收产业链去支撑它。但是如果今天我们虽然生产出了一新的材料，而且它足够的好用，而且功能性都非常的强，但是因为它现在的制造量能还不足以去支撑背后的这所谓回收的产业链，最后这个材料即便它很好，它还是只能被面临到被丢弃的问题。所以我们就开始思考说，是不是有什么样的技术、什么样的方法，可以让我们同时保留这个材料我们希望它有的功能性，但同时它又能够保持跟原来材料共同回收的一个特性。这就是我们一开始的发想。那其实这一次的我们在研发这个技术结果呢，其实是借由之前的一些研究的经验以及成果去把它堆积出来的。这边的第一个概念就是所谓的动态交联材料。那今天因为时间的关系，有可能没办法细讲。但动态交联材料本身是一个可以被回收的交联，就是可以被回收的热固性材料。那它被分解之后呢，它就会形成像这样子多关能机的寡聚物分子片段。而我们把这个东西当作改质物，我们尝试运用的另外一个我们过往研究的发现，就是微量交联的结果。那也就是说，在这个材料原本的这个结构里面呢，它其实聚酯材料大部分都是属于这种线性的结构，而当我们填入一点点像这样的节点型结构的时候，它在非常少量的添加下，它的性能会很明显得到提升，但是加了多了，它反而也会下降。这是我们之前发现一个很特殊的点。于是我们就在思考说，我们是不是可以试着用这样的改质物，结合这样的手法，去把它变成我们高质化回收的一个方法。于是我们就先试试看，先把它加在 PET 里面，再使用升级回收的方式去做。我们刚才提到，这个性质是要在非常少量的添加下才会发生，所以我们就尝试着把所有的所谓的改质比例控制在1%以下。这是我们追踪测试的结果。其实很明显可以看到呢，它这边的所谓的 Tm 以及 Td5%，这边代表就是它的融化温度以及热裂解温度。其实我们先确保是我们这个改质手法不会让这个材料本身的热稳定性得到损失，而且它加工性其实也得到了维持。再来，其实就是一个我们最重要的发现，其实是一个非常意外的发现，就是这边可以看到叫材料拉伸的一个结果。我们先确保这个材料本身它的材料应用的硬度上没有问题，也就是它的安全性没有问题。然后呢，我们测试所谓的柔软性。大家知道，其实聚酯材料里面 PET 算是比较脆性的材料，也就是它今天如果被延伸，也就是这样像前后两片拉伸的时候，它只要被延伸到原本材料的长度10%，它就会开始断裂。而我们这次的结果是我们添加了非常少量的改质比例，只有0.25% 的时候，它突然从它的柔韧性测试结果，从它的可延伸倍率从10%突然上升到了800%，所以发现在这边来说，我们突然得到一个非常明显，连我们自己都感到吃惊的结果，就是它的柔韧性大幅度的提升。那以我们研究者的角度来说，大家会觉得这个很有趣。那我们接下来试试看，是不是能用在别的地方，例如说别的聚酯材料以及别的应用方式。接着我们就试着把 PET 改成另外一个常用的工业级的材料，叫做 PPT。然后呢，我们再把原本使用的片材改成纤维材料。结果发现，同样在非常非常少的改质比例之下，这边是0.3%，可以看到它这边的性能提升不是呈现在柔韧性上，它反而呈现在纤维的强度上。这我们是得到一个非常意外的结果。所以其实我们就以这样的一个经验，然后会发现，其实真的确实以这样的方式改质，真的可以成功的让它得到良好的性能，而且在 PET 及 PPT 以及不同加工方式上面都得到不同的效果。那我们接下来就朝2个方向去进行探讨，就第一个是学理性的探讨，就是为什么它会发生，以及第二个就是实用性的探讨，它接下来该用在什么地方。那这边是学理性探讨的部分。我们最终可以看到，其实它会形成这样的效果，其实是由多重效应去产生的，就是它有微量效应的结构、链纠缠的效应以及类塑化的效应，它整的3个同样的协同效应去产生的。我们也把这样的结果呢，去成功发表在 Polymer 期刊。再来，这个技术面本身它有什么样的价值呢？第一个就是它整个材料的面，就除了材料本身，还有改质物，它全部都是以回收物为来源。再来是它的性能大幅度的提升，而第3个其实对我们来说也是观察到最重要的，因为它以极小幅度的去改质，而且它的改质方式并不需要特殊的设备，所以它在整体设备的应用上，它其实可以直接套用在现有的设备。所以我想这是一个非常具有它量化的一个非常重要的一个前提。然后再就是它环保性的提升。那我们也把这样的结果呢，除了学术发表之外，接下来我们会把它继续发表在专利的部分。那预计在今年年底我会完成挂牌送审。这个计划其实目前也都还在进行中。我们现在除了这个计划之外呢，其实院内也有好多个计划，其实都在围绕着所谓资源循环以及永续发展在进行。那其实如果未来有一些好的结果的话，也希望可以有机会在这边可以发表给各位。今天的报告到此，谢谢大家。
我们谢谢毛副研究员为我们带来非常精彩的分享，请您先行回座，谢谢。Thank you very much for your wonderful sharing. Please return to your seat. 那么今天也是一样，我们今天到最后一个环节，刚才也听了许多位讲者带来精彩的分享，接下来我们一样要进入座谈的时间。那么也是再次提醒大家，这个机会难得，欢迎大家待会儿可以用中文或者是英文来提问。一样，我们现场有非常专业的同步口译老师会为大家来协助问题的翻译。那么也提醒大家，我们在提问的时候呢，在座位的这个把手里面呢有麦克风，如果您要发言，请直接打开把手里面的麦克风，或者是如果有需要的话，一样可以举手提问，我们会有工作人员会递我手上的麦克风来让大家进行发言。Once again, I would like to remind you that now we are going to have the panel discussion, so feel free to raise your questions or comments either in English or Chinese. Our interpreters are going to translate the questions for you. Also, you can use the microphone attached to your seat. Press the button when the light is on then you'll be able to speak. 好，接下来我们就要邀请刚才这个场次的讲者回到舞台上。Now we would like to welcome back to the stage. 我们邀请 Hirofumi Sakanakura 市长，有请王雅芬教授、江康玉特聘教授，以及刚才为我们带来精彩分享的毛许义副研究员，麻烦请来到舞台上。接下来让我们欢迎主持人国家环境研究院李孝君主任秘书 ，and our moderator is Chief Secretary of NERA 李孝君。Please take your seat on the stage. 我们有请贵宾在舞台上就坐。好，主持人请就坐。接下来的时间我们就交给主持人，署秘有请。
好，非常谢谢4位讲者啊，谢谢。我是国环院的主任秘书，因为还好前一场是我们副院长主持啊。有一句话叫大哥走在前面，小弟就好走了。谢谢你们。接下来我们把时间就交给现场的来宾哈。请与会的，因为时间真的非常有限，请与会的来宾尽量提问，因为资源循环署的赖署长另有邀功，他没办法参加。如果提到有相关的问题的话，没关系，我们会把它记录下来，事后再请赖署长或者循环署来做回应。以上说明，谢谢。
好，我们现场的贵宾有没有任何问题想要提问呢 ？Any questions from the floor？ 这边有一位，来请，您可以使用麦克风，有请，谢谢。
我是，就是我想请问Dr. 萨卡拉库拉这样子，就说台湾呢，我们目前有堆存大概是1000万吨的沥青刨除料这样子，然后我想要请问，就是说日本对于这个沥青刨除料的话，它的整个资源化的做法，或是它的一些溶出的规范这样子。那以上，谢谢。
Thank you very much for question. Actually, in Japan, we recycling the asphalt pavement waste for nearly 100%. As after recovery of the pavement, asphalt pavement, the pavement will be reheated, and the asphalt is recovered, and the aggregates are separated, and the aggregates will be recycled again. And asphalt also recycled again. So it's the highest grade recycling manner, but I think the most of the recycled asphalt pavements are just crushed and recycled again to the asphalt pavement. Actually, it is almost stipulated by the Ministry of the Land and Infrastructure and Transportation Ministry. So the construction company required to recycle the pavement, asphalt pavement.
谢谢回应。在座还有尽量提问吧。我们时间40分钟。请祥恒。麻烦递一下麦克风，有吗？
谢谢。我一个问题想要问那个江老师，就是刚刚你有提到，就是在那个废弃物能源化的实作上面有遇到一些就是民众的疑虑。那我想问一下，就是目前有没有什么比较具体的方法可以让民众那个把这个疑虑放下？这样，谢谢。
OK， 谢谢，我就用中文来回应，因为看起来听众都是来自台湾朋友哈。我觉得我今天会选这个题目，我还是要表达一下，就是在所有的循环经济或净零排放过程里面，我们过去都非常着眼在所谓的源头减量，或做了刚刚很多的简报里的资源循环回收的一些技术，可是往往它回收了大部分以后，实际上还是必须要有一个能源回收的一个技术在中间去支撑整个所谓的循环经济，它不太可能是完全都是走 material recovery 物质回收， 所以能源回收扮演非常重要的角色。我今天会选这个题目，主要是想表达这样的一个概念。但是能源回收在早期谈的焚化，大家所关心的议题就是污染，还有就是非灰体渣的再利用等等问题。所以下一个阶段的 advanced 的能源化的技术的想法大概是3个。第一个应该就是所谓的低污染的排放啦。那这些技术它可以透过现有的技术，空气污染控制技术也好，或者更新的新颖的技术来解决民众的疑虑，这是第一个。那第二个当然越少的 less residue， 越少的残余物的产生的那个技术，应该也会变成优选。那是哪一个？我觉得这个见仁见智，但是至少它能够掌握的这样的一个原则，这是第二个因素。第3个，因为它既然要讲求能源化，那显然它的能源利用效率就要高，它叫是 high energy conversion efficiency。那如果掌握这3个条件，那哪一个是优选的技术？就应该可以因地制宜去找到那个多元的方向。那怎么去跟民众去沟通哈？那我觉得现在的利害关系人的沟通哈，学界有角色，学界要把技术不断的要去做promote。那另外当然公民团体应该要能够有一个好的对话。那第3个当然就是政府角色啦，政府的政策的宣导。所以我们把这个利害关系人都把它纠合在一起，不是纠结哈，把它整合在一起的时候，有一个沟通的平台，我觉得应该会慢慢让那个 solution 哈找到一个完整的一个方案啦。我这好像讲跟没讲一样，不过那个方向应该就是要建立一个 plan form， 然后让大家能够坐下来做沟通，找到那个最佳的方案。以上大概是我回应这个问题，谢谢。
好，谢谢祥宏的提问，还有江老师的回应。好，请这位。
I have a question for Mr. Sakanagakura. Yeah, you mentioned that in Japan, the recycling law, the first point is to set the target of recycling ratio, and then do the promoting. So why do you think that's so important to set this kind of a ratio as a target? And is there a kind of a big database to support this, or what kind of supporting mechanism is there that there is? And I also would like to ask another question for Professor Wang. You mentioned the importance of there's a pathway and roadmap, and also you give some example. Is this a kind of some? Do you have some suggestion for like what our the administrator says that the need to create the green business for sustainable recycling, the circular economy. Is it important to have a kind of a business model to be able to develop, to build this kind of pathway or roadmap? Thank you.
Thank you very much for the question. Actually, your question is a very, very good question. Yes. Why we set the goal of the target, 95%, for example, is because I think my opinion is first we should set the target value. Then the stakeholders can encourage themselves to achieve the target value. But actually, these days, the target value of, for example, 95% recycling ratio has already been achieved. So next step we are now discussing is to upgrade the quality of recycling. not only the recycling ratio, but also the quality of recycling should be increased. For example, not only the horizontal recycling, but also upgrading the recycling, sorting more good quality or something like that. Yes, thank you very much.
好，谢谢哦。其实我觉得台湾的资源循环产业很强，然后我自己觉得说，其实每一个公司，它在它自己的领域上面，其实是非常的杰出。那我们怎么样子把这些技术可以整合起来，去提供一个 total solution 给需要解决问题的一个对象，我觉得这个还蛮重要的。所以我刚刚有提到，就是说我们希望能够整合，然后能够让这些不同技术、不同产业的人能够一起合作，然后来提出这样子的一个解方。另外一个，其实我在后面的时候有提供2个绿色设计的一个案例。其实我觉得从源头里面就可以把绿色设计的概念导进去的时候，其实你的产品是有价值化的。所以我们怎么样子把这个整个资源循环产业能够把它给value up， 也就是说能够再高质化一些，然后让整个产业能够走出台湾，为这些有需求的东南亚国家提供技术跟管理制度。其实我觉得这是我们的强项。以上，谢谢。
非常谢谢王老师对我们做的。我想请问我们还有时间吗？差不多了。我本来想说还有最后一个问题，那可以吗？是我们想说是不是就一个问题，因为我们时间确实有限，大家如果没有的话，没有的话我们那所以是晚期吗？好，再麻烦你。最后一个问题。
我想要问一下，就是毛许博士，就是那个你讲到就高分子改质，就是很有趣这样。那想知道就是目前实验就是还在实验室阶段，还是它已经可以大量量产，就是到就是未来实际应用的部分这样？谢谢。
很感谢你的提问。那其实，在您刚才提问这个问题，其实所有的技术开发者都会面临到的事情，就是说从所谓的中小型的量产，最后变成一个大规模的一个量产情况下呢，其实中间要克服问题，其实说起来细节都还蛮多的。那我这边其实以我自己的想法啦，以这个技术如果真的要去做大规模的一个开发情况下，大家要克服几个问题。第一个就是它本身的，因为刚才所提到的所谓的升级回收，它其实在中间的过程当中，它去加入了改质材料，去制成一个新的好的再生材料。但其实就是因为这个过程中，它其实不是，它是把原来一个均匀的材料变成不均匀的材料。也就是说，它其实在里面所需要考虑到的就是每一批批次之间的稳定性，它均匀性能不能达成，它每一批制造出来都能达成我们要的效果。那我想这是很多高质化回收或者说升级回收会遇到的问题。那第二个当然就是比较现实的，就是成本上的问题啦。不过这个问题其实需要考量的点蛮多的。它其实最终我们会希望是说它的产线足够稳定，而且其实在我们刚才看来，其实它的优势是在说它的改质量很少，所以其实它所需要额外添加的步骤以及成本是非常非常少的，占比很低。所以我相信跟原来的所谓的化学回收法，它其实在成本上来说应该是差不太多。那再来第3个应该就是这个改质本身啦。我是觉得说，如果说它的制成的它的可量产性的部分，它其实说我们现在其实真的在放大情况下，其实因为我们已经确保了说它的整个制成它所需要的技术在哪里，而它只需要额外添加东西进去，它不需要整个机构的改质。所以就像我刚才讲，其实我觉得这方面是蛮有优势。那其实我们也会希望说，未来有专利申请之后呢，再以这个专利再继续慢慢去往下走，我们会继续的朝着量产方向去做测试。这样，以上，谢谢。
好的，谢谢。因为我们时间到了哈，那我们在这边作为结束，谢谢举会的呢 ，Thank you very much， ありがとうございます。
好，我们掌声谢谢语坛人精彩的分享，请主持人跟语坛人一起来到舞台中间，请往前一步。Let's have a group photo together. Please look at our photographer. All right. All right, one step to your left. 往左一步，好，请看向我们前方的摄影师。Look at the photographer. 好，看向前方的摄影师 ，Give us your big smile. 3, 2, 1, cheese. All right， 我们热烈的掌声，谢谢台上的贵宾，请回座，谢谢。Thank you to our panelists and thank you to the moderator for your wonderful sharing. Please return to your seat. 好，我们请台上的贵宾请回座。好，经过今天一整天精彩的分享呢，我们有关于气候变迁还有资源循环的讲题，相信大家都收获满满。今天的论坛就到此告一段落，提醒大家明天早上9点还有更多有关于环境治理的主题要跟大家分享，欢迎大家踊跃参加。再次感谢大家今天的参与，离开时请记得您的个人物品还有垃圾，如果有租借口译耳机也请记得归还。祝福大家有个美好的夜晚，我们明天见。Ladies and gentlemen, this concludes today's symposium. Thank you once again for your participation. Tomorrow morning, we are going to start at 9 o'clock. Before you leave, please don't forget your personal belongings. And also, if you have borrowed the interpreting headset, please remember to return it. May you have a wonderful evening and see you tomorrow. Thank you very much.